Okay, any other problems with Compose that come to mind? I know that you're not a fan of the navigation library, right?
Oh man, that's a fun topic. Okay, yes, that's one way to put it. I am not a fan of Navigation Compose. In fact, I admire what they are trying to achieve in the sense that
Welcome to the Coding in Flow podcast. My name is Florian Walter. I'm a self-taught programmer, and in this show I interview interesting people from the programming industry to learn from them about software engineering, career development, and life in general. In this episode I will be interviewing Gabor Varadi, who many of you know under his nicknames Zhuinden on Reddit and EpicPandaForce on Github. And Gabor is really well known for writing these very long, very elaborate and helpful answers in these different communities. And he also writes very insightful Medium articles. And Gabor is one of the most passionate, most knowledgeable Android developers I personally know. And I often go to him when I need advice. And this went so far that we even created a course together a while ago because I felt much more comfortable preparing the code for this course with his knowledge rather than doing it all by myself, because he has so much experience. Besides writing these long answers in communities, he also gives live talks. Some of them will be linked in the description of this podcast. And he works as an independent contractor, as an Android developer. And he doesn't only work on small apps, he works on really big, complex, production-grade apps. And because of this, he also has real-world knowledge, and he sees problems in different libraries that other developers might not see because they didn't work on such complex apps. And in this episode, we will talk about some of these problems. For example, what are the problems that Jetpack Compose brings? Because it's actually not all just sunshine and rainbows. Compose has its very own problems, and a lot of the stuff is not as straightforward as you might think. We also talk about reactive programming and what the benefits of it are and how to do it properly. And Gabor is also very notorious for not being a fan of the MVI architecture. And in this episode, we will talk about why that is, why he prefers MVVM, and what, in his opinion, is bad and wrong about MVI. Because this episode got so long, about 3 hours, we decided that we split it up and schedule a second part where we will talk about some more topics like testing and clean architecture. The second part will be recorded soon, so stay tuned. Don't forget to subscribe to this podcast. And then I wish you a lot of fun with this episode. Okay, so let's start talking a little bit about you. Maybe you can tell us what you do in your personal life as much as you're comfortable with sharing, what your hobbies are, and also how you got into programming and when you first started programming.
Ooh, that's actually an interesting question. Hold on a second, let me think a bit. Like, as for when I got into programming, it's actually later than people would assume, because my brother used to be into programming. He was programming since he was like 6 or something. So it was more like he was doing it. And I was like, hey, this looks cool. But originally, I mostly learned programming at school. And then I went to university. And I eventually got a bachelor's in computer science. Technically, it's computer engineering, but it's almost the same thing, question mark. It probably is. So in that regard, it was more so when I was like around 16, 17 that I really started. And then when I entered university, then they were telling you the basics, which you kind of had to know to like keep up. I already knew that. Then obviously when they went into OOP, like object-oriented programming and stuff, and classes and constructors and all that, that was all new. I had no idea. So I learned most of the basics of what people take for granted these days at university. So in that way, it's not like it was an unattainable thing that you had to know back when you were like 13 and always doing everything, like winning competitions and whatnot. No, like that wasn't me. My brother did win competitions, but yeah, I'm normie. I'm a normie in this regard.
So would you say that your computer science degree was worth it?
it was worth it for the basics, although obviously after like you spend 7 years in actual work, it kind of gives you a different perspective on certain things, like some things that you took for granted that this is important. You realize that none of this was actually important, or at least not in the way that it was taught. Like, for example, what I think had a lot of focus and was not the actual focus, it was design patterns, like, the gang of four, factory patterns, singleton pattern, all that stuff, especially when you get into things like flyweight, abstract factory, and all that. I don't know, there are like 25 of them. That's not the important thing. That's how you end up with code that's named like abstract singleton proxy factory bean, which is a real class in Spring. Like that is a real thing. It's also kind of a meme. People know about it because, well, I mean, what does it actually do, right? Like, it's both a proxy and a singleton, and it's abstract, so it doesn't actually know what it does. Like, what are you doing, dude? Like, who uses this? What do you need this for? So in that regard, yeah, and that comes from this obsession with design patterns. That's not the important thing. The most important thing is creating behaviorally correct code. Did I answer the question? I'm not sure if I did.
Yeah, that's how you got into programming. And the other part was, what do you do
was
in your
the
personal
computer
life?
science degree verdict.
Okay,
Well,
yeah.
yes. They did teach some super important stuff as well, though. Like, even, for example, how to manage relational databases and schema normalization, and what else was there, which was important? How do queries work, how to optimize them, but most importantly, how to normalize a schema. Because on the internet, people ask a lot, how do you even model this, that you have a many-to-many relation? And you learned at university that you need join table and foreign keys and whatnot, but people who don't know this, they had no idea. And then you try to find the answer on Stack Overflow, someone explaining this, and you can't find it. It takes me like 15 minutes of searching to find this. And I think the example code was Python. Like, it says if either everyone knew this or nobody knew how to ask the question. These are the two options that I see, but it's really hard to find.
Yeah, I think we even learned a little bit about relational databases and normalization in business economics degree, if I remember correctly, but not to such a high degree, just some basics about it.
It's super important for even Room, because even though it tries to like be an ORM and hide things for you and do some things automatically, for querying, you still need to manage the join tables as classes and insert them as classes with Room. It's not the case with Hibernate and stuff like these higher tier ORMs, but with Room you do need to know about these details. So without that, I don't know how you create local databases on Android.
Yeah, the other part of the question was your personal life and what you do in your free time. I know that you play board games, right?
I do have a board game collection. Should I show you like one?
Yeah, of course.
Okay, just a moment.
Yeah.
I need to grab like one.
Of course, the people in the audio version will not see it, but that's fine. If you want to see Gabor's board games, you have to watch it on YouTube.
This is one board game.
Yeah, nice.
It's heavy. Yeah,
but why is it 4 different boxes for one game?
Because this is the Underworld expansion, this is the River Folk expansion, this is the actual game.
Wow.
And I think this is the Clockwork expansion, which means that it's AI if you wanna play alone, but if I'm alone, then I don't play board games.
Okay, so the name of the game is Root.
Yes.
What's the game about? Is this like an RPG, or how can I imagine it?
Okay, so
is it like playing a role-playing game?
No. Okay.
No.
It is a board game. Like, it's not an RPG. It's not like Gloomhaven, which kind of really is an RPG. You have a board. There are different factions. In fact, Root is most well known for being an asymmetric board game, to such degree that every faction has a completely different rule set, which means that their game mechanics, their actions, their conditions of winning, how they earn points and all that, they are all different. Like there are, I don't know, with each expansion they brought in 2 more new factions, and originally there were 4. So there are now 8 factions. I will eventually have even more expansions. I'm not sure when we'll actually play it, but still. So the way you imagine it is that there are like, okay, so there's a forest, and the animals, the critters in the forest are fighting to decide who will rule the forest, or at least that's what I say about the cats and the birds who are fighting. But in reality, there's also the alliance that tries to like, hold on a sec. It's kind of like in Star Wars. They are the rebels. They are like spreading propaganda. That's actually their move, spread propaganda. And they try to like get sympathy from the forest creatures to fight against both the birds and the cats. And then there are also vagabonds, which have like 1 unit. They are not a large faction with like all these buildings and stuff. They are just moving 1 hero around, and they do quests and they collect stuff and they interact with the other factions, and they get points for like killing some from this, trading with the other one while you're doing stuff like that. So all of them have completely different rules, and in the end the game boils down to whether you can get 30 points sooner than others. But as I said, everyone has a completely different mechanic for that. For one, there's also this one trick where you can like redefine your win condition if you feel like you're not gonna be able to get 30 points, which is called dominance. And then you need to take over certain sections of the map and then keep it for a turn, and it's really hard.
Okay, so this was a crash course on Root.
This was a crash course on Root. It's fun.
And how many people do you need to play such a game, roundabout?
For Root, you need at least 4, otherwise it won't be fun.
But I think it would be hard for me to find so many people that also would enjoy playing a game. You need special kinds of friends to play these games. I mean, you need friends that also enjoy board games. It's really uncommon, I think, at least here.
Is it?
Here, people would rather spend a Friday night going at a party than playing a board game. And I can't blame them.
Yeah, but, well, there's a trick to this, Timmy, that, like, you have one friend who likes board games, and then you befriend their friends.
Or you can turn it into a drinking game. I guess that's what many people would enjoy.
You can do that. There are people who do that. I don't think we ever did a drinking game, so I can't help with that, though.
Yeah.
And on top of that, I got into Tetris this year, but that...
Oh, yeah, I noticed that.
Yeah.
And you do some live streaming of that, right? So people can check it out.
Yeah, on Twitch every 5 or 6 days or so.
Yeah, what's your username on Twitch so people can check it out?
Zhuinden. So it's like Zhuinden, but without the I, and it's Zhuinden.
Yeah, I can put that link into the show notes if you want. If it's important enough for you, then I can put that link in the show notes.
They can check it out if they want to see what Tetris looks like. Like, people have a preconception of it, but it's based on like the original NES classic Tetris, and this is not it.
I had the idea that you could do this and talk a bit about programming on the side. What's about this idea? You were thinking about doing that, right? So it would be more interesting for more people, I guess.
Yeah, I was considering that, but then I thought about how the Twitch revenue model just... Like, you either get people to subscribe to you, but Twitch still takes 50%. 50% for each sub, and on top of that, during streams you would get revenue from it only if people cheer, but for that they have to buy bits that they specifically use for cheering, and people don't really seem to do that. Like, there's a few who do, so I was like, you know what, I'm just gonna keep it separate.
Okay.
I can talk about Tetris as a state management game, though, but I don't think that's the focus of this talk.
No, not of this one.
No, not of this one. It's a fun concept, though. Like, I have a feeling that if you... Okay, I want to say this because I was thinking about this earlier, but, like, there's this meme about how inverting a binary tree is something you need to know to, like, get hired for a firm.
Yeah.
I think just seeing if people can like be good at Tetris would be a better indicator of whether they are good at like mentally modeling the state of a system than whether they know the algorithm for inverting a binary tree.
Yeah, Tetris has a lot of benefits. I also read somewhere that Tetris actually can prevent PTSD if you play Tetris right after something bad happened. For example, there was an accident and you saw like blood or dead people. Then if you play Tetris soon after that, like a few minutes after that or an hour or something like that, then I read that it overrides certain parts of your brain and then you don't have these images later that people can get when they have PTSD. But I don't know if it's BS or if it's actually legit. Okay, so that's your personal life. Then next we can talk a little bit about Jetpack Compose.
Oh, nice.
If you want. So I know that you have already worked with Jetpack Compose. Maybe you can summarize a bit what your experience is with Jetpack Compose and what problems you ran into, because I know there were problems you had, and how it compares to XML.
Okay, so these are actually really good questions. But what I will start with first is what is Jetpack Compose? Because everyone knows, well, not everyone knows, but now they will know that it's supposedly a UI framework developed by Google to replace views. That's what people often tell you. But that's not the case, okay? Like the Compose itself is a runtime that analyzes your source code structure. It goes through your code as to how things are nested, these conditionals and these for loops and all that stuff. Each of them is a block and each of them is assigned an ID because your code doesn't change dynamically. Well, you can change it, I think, if you really want, but it's against Play Store policies anyway to do that at runtime. So your code is static. So they're like, you know what we could do based on this? Assign IDs to everything. And after that, they have this tree built from your code, your actual structure of your code, and they transform that into whatever they want. So Compose UI is actually a transformer for this tree that is generated by the Compose runtime, right? So what do you get from this? They get diffing as like, for example, a condition changes, like if true becomes if false, then it detects this change, and the Compose runtime composable annotation is needed for this specifically, that it detects, it starts tracking the changes within the code in this regard. So when this condition changes, then the UI changes underneath. And this is all done by the Kotlin compiler plugin that they have. Like, it's pretty magical, to be honest. But the important thing here is that it implements this diffing as you change anything, any incoming parameters, because they analyze the functions themselves and the structure itself. Okay, so that is Compose. You now know it is actually a way to transform code structure into something. And something that is a nice tree structure that you can create from a tree structure is UI. So that's the magic behind it. So where was I going with this? We did use Compose indeed, yes. And there are good things and bad things about it. The good thing is that Compose does bring you on its how do you say this in this language? Hold on a second. Oh yeah, delivers, that's the word. Okay. So Compose does deliver on its promises in regard that when anything changes, that is immediately rendered on the UI. Like, you don't have this trickery going on as you did with two-way data binding, where if you don't do what two-way data binding does, like for example, a simple view-related bug that if you call setText, then it overrides your cursor. So if you were to do two-way data binding against an edit text yourself, then you need to track the cursor position because it becomes 0. Like with Compose, it doesn't do that because it was built to handle changes coming from outside instead of the state being managed internally. That doesn't mean that you cannot have state managed internally, and we will definitely get to that because it's interesting. But basically, the way you can imagine this is that in Compose, the UI is always two-way data bound to the incoming state. Like anything that is wrapped as state and therefore observed as state and coming in as a function parameter, that practically is two-way data binding. But you just write standard code. You don't need to think about it. There's no magic. There's definitely no annotation processing. There's no like these fancy binding expressions and all the overhead of the generated code. Like that is generated by the Kotlin compiler plugin, but you never see it. You don't need to think about it. It doesn't break your build process. So it doesn't have all these shenanigans that data binding does. And you definitely don't have binding adapters, which is amazing because binding adapters were like the bane of Android code, to say it that way. Like people were abusing them in ways that they shouldn't have. But back to Compose. So the way you can imagine this is that you can change any variable anywhere, including your view model, because you probably are using one or something equivalent, unless you just throw everything into a composable, which is also an option. People are talking about it, how you probably don't need view model anymore, but that's also an interesting topic. But so let's say you do have a model, you change it. It is observed because you can have it in a live data or an Rx observable or a state flow. It doesn't really matter. It's collected to, subscribe to, or observed as state, which means that it is converted into something that Compose knows about. And then that's the thing that you actually pass, like you pass the function. The dot value you get there, it is passed to the function, and that function will be reevaluated each time the state is modified. And this is what Compose tracks for you in the background. Yeah, the important thing here was that it delivers on this. Like there is no bug about this. This actually works. So I'm not surprised that they released it as a stable in this regard. Like this works, and it's actually quite fascinating that it does, because it's pretty magical.
But when you say it works, what would you expect to not work about this? What bugs would you expect?
That's actually a fun one, because you actually can run into very cryptic things if there's a version mismatch between your Kotlin version and the Compose version. And if you're really unlucky, then your Compose version and the Compose compiler version. Like there was this particular bug where I got something like begin index does not match end or something like that, and that's practically what you get. And you get this huge stack trace from appliers and whatnot, and you're like, what am I even looking at? And the solution was to make sure that the compiler plugin has the right version. And this crash only happened when I tabbed 4 items and then navigated 4 forward. If I tapped 3, then it didn't. And I was like, what is this?
This was with Jetpack Compose.
This was with Jetpack Compose, yes.
And what caused this?
I don't know, version mismatch? Like something to do with the generated code, right?
Okay, interesting.
Yeah, like this kind of arcane stuff can happen. So that's actually a downside of Jetpack Compose. You need to depend on a specific minor version of Kotlin, the specific one that is specifically supported by that particular version of the Compose compiler plugin.
But doesn't Android Studio warn you about this if they are not compatible?
Well, yeah, it just it makes your build fail. It says that this Kotlin version is not supported, but don't tell us we didn't warn you or something like that.
Okay. So when you had this bug where your app crashed when you tapped 4 things, were you ignoring this warning, or how did you get into the situation?
Okay, so the Kotlin version was correct. The problem was that there were 2 different versions of the Compose compiler plugin and Compose. So those became mismatched. Like one of them was like, I don't know, let's say beta 10, and the other one's beta 11 for some reason. And that's when it was like...
So to avoid these problems, we just have to make sure to use compatible version numbers.
Yes. The tricky thing about it is that it was a runtime crash and it was very elusive. So that's something that people really need to care about. You need to use the right versions.
So those were some problems you ran into.
Well, one of them. Yeah, I can also talk about like UI tooling wise and just tooling wise in general, that so the build process is working well. Like you don't have the problem that you have with data binding, that if like every third build you do, it fails and you clean the project and then you pass it to run it and then it just works. Like Compose doesn't have this sort of problem, but the tricky thing about Compose is that if you used to rely on the XML preview to, like, for example, you cut out the image from Figma and you put it in as a background and then you position stuff to have like the right margins and all that, which is something that we used to do for complex UIs, but you cannot really do that with Compose because the way the preview works is that the preview requires a fully buildable version of your code, so you cannot have like half of it done, half of it not. Like the whole code base needs to compile for one, and for any change that is not just like a live literal, as it's called. So like if you need to add padding to something, then you say modifier equals modifier.padding and this number. Then you modified the structure of the code and therefore it needs to be recompiled for the Compose preview to be able to render it. So that means that if you like forgot something, you added a new view, you added like anything really, then you need to recompile the project, which is great when it's fast, but eventually it gets slower.
Yeah, literals don't require a rebuild, right? When you change text,
live
for example.
literals don't. So text and numbers. So if you have this modifier padding 16.dp, then if you change that to 24, then that's a live literal. And that's evaluated by the preview right there and then. You don't need to rebuild for that.
Right, but if you add padding when there wasn't padding before, then you have to rebuild it.
Yep.
And what do you think about the preview in general? It feels a bit weird to use. It's slow compared to XML.
Well, the slowness mostly comes from this that you have to rebuild so often for it. So in the end, you end up like writing this large chunk of code, hoping that it works, and then you wait for the build and then check the preview. And if something is wrong, then if you replace something with a row or I don't know, like you need to mutate the structure, then you rebuild again and again. And after some time, this actually took more time on some complex views. No.
In my case, in my small app, I was faster actually starting the app and navigating to that screen than waiting for the preview. The preview was even slower than starting the app for some weird reason. Because I have to build the app in order to start it, right? Yeah. But I don't know why it was slower. It was significantly slower.
Wow. Okay. I did not experience that. I did experience that sometimes Kotlin just like messes around for a long time and I waited 2 minutes. So that was fun. Something I ran into, which I guess it's partly more like the API just didn't work the way I expected. Constraint layout. Sometimes there were cases when we swapped out the constraint layout to fix a crash. So that was fun. But on top of that, like there's this dimension parameter that you have to set on a constraint layout where you have to explicitly say that it's field to dimension field to constraints. I think that's what it's called. And if you don't know about this parameter that you have to set it, it's practically doing the same thing as when you need to set the width and height to 0 dp for the constraints to work. But setting something to 0 dp is a bit more obvious than having to remember that there is this other dangling parameter elsewhere that's like totally optional, that if you don't set it, then your constraint layout just refuses to care about the constraints you define. Like, I wonder why it's not the default. There are some strange API decisions there.
Yeah, I read a tweet about it from you, I think, earlier today about this problem.
Yeah. Because it's so strange. Like, you have to there are these things you have to remember, and that's almost a Compose job because there are so many things you have to put in a remember block in Compose. But for real, you have to remember that this property exists, and that if you forget it, then it just flat out doesn't work. It pushes your views out of bounds and stuff. And I don't know why that's the default. Like, you could redefine it to like, yeah, I don't care about the constraints, right? But this is a constraint layout. You would think that the default is for the constraints to like be taken into consideration, that you don't go out of bounds when you set a text view to be like between the parent and this view on the right, and it just goes off the screen.
Yeah, just want to mention
what?
that if people want to stay on track with these problems, they can follow you on Twitter because you post this stuff regularly.
Yes. I
whenever
did
you
post
run into
about
something.
it.
Yeah.
And then people eventually told me that you just forgot dimension fill to constraints. I was like, why is this not the default? Like, is there ever a case when you actually just wanna push your views out of bounds? I don't know. That's weird.
Yeah, so I'm not 100% sure how I can imagine this. You set the constraints, but
if you forget this dimension parameter, then the constraints, like you say that I want this view to be the left constraint to be the parent, the right constraint to be this view on the right, and the way it does it is that it pushes it to be left of the view on the right, but it doesn't resize it to be within the parent. So it tries to put it there and it fails and it just goes off the screen. Like the whole thing is just out of bounds.
But it can be fixed with modifier.
This dimension parameter, yeah. So technically you can configure it, but it's just not obvious. And well, yeah, you can read the manual. It does say that you need to set this parameter, but it's kind of strange to me that it wasn't like a property of like the constraint as modifier, for example, because you're probably using that anyway. So at that, or within the constraint scope, like you would pass it. I don't think you modify this later, but even then this is Compose. So if you change it, it would like reapply immediately. So I don't know why this property is optional. Technically, that's what I think about.
Yeah, I really enjoyed using constraint layout in XML, but I haven't used it in Compose yet.
I also love it in XML. You need to take that into consideration.
Yeah, but in XML, I know that you usually write XML code directly, right? I actually like the visual editor where you can drag and drop these different constraints. For some things, I found this very useful.
I have not used the visual editor in years.
But a visual editor was really useful in situations where you don't actually know how to achieve in code what you want, how the attribute is called that achieves what you want, and then you can just drag and drop these handles and it would do that for you. So this was, for beginners, I think this was easier.
Oh yeah, I definitely used the visual editor at the very start when I didn't really know constraint layout. I'm not saying that I was using it to create UI. I was using it to see what properties constraint layout has. And then I went into XML and I changed it up according to my new understanding. So
yeah, after a while, almost everyone started writing a lot of the stuff directly in XML because it's just more efficient.
It is, yeah. Like I saw that there's this really cool button in the visual editor called infer constraints.
Yeah.
And then Android Studio tries to infer the constraints.
But did you find that actually useful?
I don't use it. I don't use it ever.
Yeah, I didn't find it so useful either. The only thing I used it for, I think, was when you put your first view in the middle of the screen and you want to have match parent constraints. Or add all these constraints to the sides of the parent. Then you click this button and then it does this for you, rather than having to add all these constraints manually. But this was basically the only thing I used this for, but not for anything complicated. But yeah, I think the idea of this was to put all your views without constraints on the screen, press this button, and then it connects them so that they stay in place, basically. But if you want anything that's a bit more advanced or anything complicated, then this won't do this for you, obviously, because it has no idea how exactly you want to have it. Yeah, what I like about the previews in Compose is that you can add multiple different ones of them. This seems useful. For example, yeah, you have different kind of states for your screen and you can add previews for these different states and you can all see them at the same time. This is really cool, in my opinion.
I definitely agree with that because anything that you want to make configurable, you add it as a function parameter and then your preview can just like swap out something that's like a true to a false or change the items that you render, or you can even just pass in like no view, and no items and some items, and then you render the empty screen on one preview and the list on another, and that actually works. That actually is really nice. And with that same setup, you can like check if dark mode is working or not. Like for example, that one of your previews is light mode, the other is dark, and it just shows both of them on the side. Oh, that was a fun one though. There was this minor issue that the screen was like growing kind of long, and I was like, okay, but how do you make this scrollable? And you cannot scroll it. You can't scroll the preview. What you can do though is redefine the height of the preview and make it like 2000 dp big, and then it works.
I had a problem that I sometimes added fill, how is the attribute called? Fill size or fill width and fill height, the modifier. And sometimes, even though it worked in the final app, the preview would break because it would make the preview extremely long because of this one composable. But this is not how it actually looked in the final result. So this was some kind of bug, I think. But there were situations where it completely broke the preview for me because the screen would grow really large and then I can't view it in the preview anymore. Did you run into this yet?
No, I did not.
The next time I run into this, I have to tell you about this or show it to you.
Interesting.
Because I had this a few times.
All this talk about previews reminded me of something that's super interesting, which is the required level of separation to make the previews work in Compose. Like, if you saw, there was a PR saying that now we support view models to some degree in a preview. I'm not sure what that really means, to be honest. But what is important, though, is that like you need to be able to set things up for the preview to work, right? Like you need to pass things in, and to pass things in, you need to create them. So something I ran into is that when there was no real separation because, well, it was like our first third composable or something. So just directly pass the view model in. And so we pass the view model in, and for that we create it with the constructor, and the preview tells me that retrofit is crashing in the preview. And I'm like, what? And it's because there was a retrofit parameter that was needed because of the API error handling, right? Like for that you need the retrofit instance. So we were like, you know what, let's just cut some corners because this is the very start, we'll fix this later, blah blah blah. You know how that works, that always stays there forever in production. But oh well, that's not the important part. The important part is that if you needed a retrofit in your view model, then retrofit tries to also be created, and in the preview, it would try to detect what platform it's on with reflection, and it fails. It fails to be created. So at that point, you're like, okay, so that means I should not pass in any external dependency into this composable. Otherwise, it can potentially break the preview. And that's when you end up like separating it so that the incoming parameters are either data or something that's like an event handler, like a callback of sorts. And for that, higher order functions like onTextChange, string, unit, that sort of thing. And then you'd never see the view model. You can pass in something like view model, semicolon, is it semicolon, the two dots?
Just colon.
Colon, yeah.
But I think the operator has a special name. You mean the two colons right after each other, right?
Well, it's the function dereferencing operator, yeah, when you get a function reference. So what you can do is have this function like something that takes a string and returns unit, and then you just use this double colon operator to be like view model, two dots, and onTextChange, let's say that, because, well, I know no better name coming to my mind at this moment. But so you can pass it in that way, and then you don't need a reference to the view model anymore. And you do that a lot. Like you do that a lot. So that's why a lot of people ask, hey, I have this composable that's like taking these 8 parameters and these 9 callbacks, and what do I do about it? And then people try to make these interfaces to like reduce it, like, yeah, I only need like one interface, but you still have these 9 functions. So technically you didn't really change anything. It's still almost the same. So in the case of composables, I actually found that I did not extract an interface for this because, well, the composable would be able to define a contract in this regard that I need these 9 functions to work. But in a composable, you cannot really define a class unless you do magic shenanigans, which you can, but nobody does. So in that regard, I'm like, so where do I name it? Do I just really actually put it next to this composable? But then in discoverability wise, it's not that good. So at that point, I was like, you know what? I'm not extracting this interface. I just pass in 8 callbacks. It's fine.
Yeah, interesting, because I actually do pass an interface that I have in the view model. So my view model implements this interface that contains all the methods that a composable screen can call on the view model. And then I have the benefit that I can just pass this one actions object, as I call it. You gave me this tip, right? Calling it actions. I only pass this one object down to the different composables, and they can then directly call these methods. And what I avoid through this is having this huge list of methods, method callbacks, and arguments in the outer composables that contain the whole screen. Because this was the problem. This grew huge, right?
Yes.
And this is also what you're talking about.
It's exactly what I'm talking about. So I did tell you that tip saying that this is something you can do if you want. In our code, I eventually opted not to extract an interface. So we just like kept the argument list.
So you have these large lists of arguments in your composable functions. Some people were mentioning, when I talked about this problem, some people were mentioning creating these state classes, but this is something different, isn't it? Because in the outer composable, you have to unravel them.
You have to unravel them anyway, like you're going to access it from that object or that callback interface. Yeah, the state object is a different thing. The state object is a way to alter the state of something from the outside. This is most notable if you check things like the bottom sheet dialog as it works. Like you want to make it expand, but you cannot expand a bottom sheet rendered by Compose because it's a function. It's a composable that returns unit. It's not a thing that exists. So what's a thing with which you can communicate into the bottom sheet dialog so that it triggers a change that can be rendered? That's the question that we are asking. And the answer to that is a state class. You pass in, actually, yeah, you get this remember bottom sheet state. Let's go with that. And it has a function called expand, and that's what modifies the state internally. And this state class is what is also rendered by the bottom sheet. So as such, it's a way to extract internal state to the outside so that both the outside has a way to mutate it and trigger changes on the inside, but it also works on the inside because it needs it to render.
Okay, but what's the difference then? Why can't we just pass a Boolean value for the expanded state in, and the animation is then handled internally?
In that case, it's because it's a suspending thing. It's like, I guess they could have used the launched effect.
Because I went through these code labs from the Compose pathway that people can find in Google, and they basically said if you have composable functions where you have like argument and callback to change it and multiple of them, then you should create these state classes that just encapsulate them so you don't have so many arguments. So this is what I recommended basically, if I recall it correctly.
I have to look at it again because I know which one you're talking about, but I need to check again.
But what I was going at was, I think with these states, if you do this for every composable, then you could
there it is, creating a state holder. Oh my god.
Then you could decrease the number of arguments you have in the outermost composable, right? Maybe you can cut them in half because you always combine one of these arguments with one of the functions.
The reason why we eventually just didn't do this interface thing is because the internal composables don't need to care about every function. So at that point, I end up like splitting up this thing that I put together. And I'm like, why do I compose this thing together if all I do with it is decompose it again? But where am I going with this?
No, but what I meant was when you create these state classes for every composable on your screen, then you end up with fewer of these method arguments, I think, function arguments in your screen composable. But I'm not 100% sure right now. But maybe we are going too much into the detail about this.
Nah, I think this is what people enjoy.
Okay.
The real question is whether we have an answer. My answer is to be pragmatic about it. So in this regard, when it was like, it had 12 parameters because I had like 7 data and 5 callbacks for change, then I was like, you know what, there's 12 parameters, but this is practically how composables work. So I don't care. It's fine. Like, it works perfectly fine. In fact, if you separate it this way, then you don't need to care about like if you have your data, then you need to annotate it with immutable and stuff, so that Compose knows that this is an immutable thing, and then it detects internally with content equals and all that. But if you have these fine-grained parameters, then Compose only checks those parameters. So the more it's split up, the better Compose can optimize for getting diffs, like for observing changes. And that's the reason why I'm like, you know what, it's fine. Like, if you have these parameters, and these are the parameters that Compose observes, I don't need to think about how my structure affects Compose, because it is the most destructured way of passing this stuff in. This is what I need either way, so it makes sense that the composable expects these parameters. I look at it, I know exactly what it wants. And the exact reason why I was like, you know what, it doesn't matter that I have too many arguments, like why would I try to cut this down when it doesn't give me any notable benefit beyond cutting the number of arguments down, is because if you ever looked at text, you're trying to use the material text in Compose, it has like 20 parameters. And I'm like, you know what, let's just go with it.
Right. But why do you not like the approach where you have the ViewModel interface so you can cut down on these function parameters?
I wouldn't mind it, but I would want to create the interface as like a nested class.
So you don't want small composables to have access to all the methods that it shouldn't care about.
Yeah, that's these two things, yes. Like the small ones, they don't really care about all the other things. They only care about like on-text change, for example. And then I want to pass in on-text changed to that composable. I guess you can technically pass in an interface to the big composable, and the ones inside it would just get like actions, colon, and on-text change from that action. And then you can like have a hybrid approach where the small ones don't see everything, but the large one sees it as one argument list, so that it's not like this unsightly, huge block of code.
I just want to clarify for people what I mean. The problem right now is you can't, maybe it's not a problem, but right now you can't pass a view model down to composables as you can, but you can't show it in the preview. This was the problem, right? You can't
I'm not sure. For me, just creating my view model, which had a dependency on retrofit at that time, it made it so that retrofit couldn't be created, and you needed an instance. So then you have this, you start to wonder, should I make retrofit nullable so that I can pass in null at the start so that the preview would work? And you're like, this is the opposite of what typed nullability was made for.
Yeah, and what I'm doing right now is I simply have an interface in the view model, and then I can, instead of passing the view model itself to the different composables, I pass that interface. And the benefit is that in the preview, I can then just use an empty implementation of that interface and it won't complain. So this is how I basically pass down the view model to these different composables. And why I do this so that I don't have these lots of different function arguments that the screen composable has to take in. Yeah, just to clarify this for people.
Yeah. I think either approach works, because at the end of the day, we're literally just trying to pass some number of functions in some shape or form to a function. So like, whether you pass 8 of them or one interface that has 8 functions, I don't think it really changes anything. In the end, in the previews, we also just passed in these empty arguments. The important thing was solving the issue of like not having to depend on retrofit for a preview, because that would break the preview itself. Like it would literally fail with an exception during the preview process. So as long as you fixed the issue and it's like not adding too much extra complexity to your code, it's fine either way. Like the reason why I went for like keeping the argument list is that I don't want to introduce new concepts into the code that are not needed for it. That's what I felt.
Okay, any other problems with Compose that come to mind? I know that you're not a fan of the navigation library, right?
Oh man, that's a fun topic. Okay, yes, that's one way to put it. I am not a fan of Navigation Compose. In fact, I admire what they are trying to achieve in the sense that they want to create the framework that manages lifecycle owners, ViewModel store owners, safe state registry owners, and all that stuff without fragments that encapsulate them and act as this thing, right? Like this is the end goal. The goal is to swap out fragments with nav backstack entries. So as long as the nav backstack entry can do anything that the fragments can do, they can act as a replacement. So as such, the most important things that Navigation Compose is currently doing internally, which is actually something that makes perfect sense if you're trying to create something that interoperates with Jetpack and its architectural components, is setting up the local ViewModel store owner and the local safe state registry owner and the local lifecycle owner to be the nav backstack entry of the current destination that is being rendered on the screen, right? Like that's what it does. And that's great. I wish that it had an API that was type safe, but it doesn't. I'm not sure why. Like you had navigation originally, like Jetpack navigation. They had safe arcs. Safe arcs had problems. Safe arcs had very notable problems, which I guess I will explain now. There were two of them. One of them is that you couldn't define a set of parameters that you would include in one argument list and on other argument lists. So what you needed to do for safe arcs to work is define the arguments on both the action that navigates from A to B, and you needed to define it on the receiver side, that is B, so that it can receive arguments that are coming from the action. And what's even worse is that if B was a start destination of a nested nav graph, then you also had to define these arguments on the navigation tag as well, so that it would be able to delegate it from the nav backstack entries arguments to the fragments arguments. So you defined the same set of arguments three times with strings. And if any of them have a mismatch, it won't fail. What it will do is just give you nulls. And that's not that great. Like imagine that you have to like explicitly remember, oh yeah, this string here, it has to be an exact match as this other one. And you cannot extract, well, technically you can put in your strings XML or somewhere and then refer to the string per se, but you still cannot include the type. The type has to match. And if you change it in one place, you have to change it in all three places. And if you navigate to this screen from another action, like another fragment and another action, then you have to define it there too. So you duplicate the same list of arguments as many times as you navigate to something.
But we are talking still about fragments or about...
This is still the fragment version.
But
we'll get to Navigation Compose, okay?
Yeah, but I'm not sure if I can follow you, because how I remember it was you added the arguments to the destination in XML, and then when you used it,
needed it on the action.
And then you used the generated code, but the generated code then automatically had these parameters from the arguments
you defined in XML, which you
but this was just one
in at least two places, because you had to define it on the receiver side and you had to define it on an action if you were using an action to navigate, which you probably are. Because in order to have the correct animations, you needed an action which defined the pop and push. Is it push? Pop enter and pop exit, that's the one, and enter and exit. So these four animation parameters. So you were using action to navigate from a fragment to fragment, but then you needed to define these arguments in these two places. And as such, it took a bit of time So like it's not the matter of time. The problem is the duplication. But this is SafeArgs. This is the fragment world, the XML navigation world. So this is the original thing where we had some semblance of type safety. And then one thing that it still had, SafeArgs was able to pass parseable and serializable arguments and enums and arrays as long as you defined it with a fully qualified name. And if you enabled ProGuard and you didn't keep the name of parseable objects, then it would crash in release mode. So that's great. This is something I heard the other day. I was like, wait, really? And yeah, really, because it uses class.forName to load it.
And we can't send parseable and compose anymore.
Yes, with Navigation Compose, they were like, you know what people really liked? Being able to pass objects. You know what we shouldn't support at all, ever as a concept in Navigation Compose for some reason? Passing objects.
No, I read their reasoning about this, and I think what I want to encourage is that you just send the ID of an object, right, and not the whole thing, because it's, I guess it's more efficient, faster. I'm not sure what's bad about passing but okay, one downside maybe of passing an object instead of the ID is that you have data that's then not observed, but just the static data that you send over. But maybe sometimes this is exactly what you want. But if you want to get an object and then observe the changes in it, then you need the ID anyway and retrieve that from room or whatever you're getting it from. But yeah, I think they want to encourage sending the ID, right, and not the whole object. But what do you think about that?
I think exactly what you said. So there's a lot of times, especially when you have a local DB, it's in the database, it can be updated from the remote data store if it's a thing like API, you save it and it can change underneath you and you want to show the up-to-date view, which makes perfect sense in
like a detail screen.
Yeah, like a detail screen. Like if it's a read-only screen, then obviously you don't want to send this object, have this copy that's like completely unbound from the local data store, and instead you would have this in-memory copy that is no longer updated in any way.
But sometimes you do want this.
But sometimes you do want this. And in that case, Navigation Compose tells you, yeah, you cannot do that because on the web you have a URL string. So we thought that's a great inspiration for Android, which is not a web app. That's practically the reasoning here.
What about size constraints? Is it maybe possible that these objects can become too big to send between screens? Or is it not an issue?
Okay, so that's why this is funny, actually. This is why it's super funny to me, actually, because the fact that you cannot send a parseable or a serializable, which is a byte representation, like a binary stream representation of your data in some serialization format, that doesn't mean that I cannot do this with strings, you know? Like, I can literally grab my
Turn into a JSON.
Turn it into a JSON or a protobuf or anything, really.
Right.
Throw it into the URL encoder and then append it to the query string. I'm like, this is my object, let's go. And I send this huge JSON as part of the
But I
string.
can discourage it maybe by making it not so simple to do.
Okay, but it's not actually a problem. Like, it's a problem if you have this thing that you want to update. In cases where you don't, what do? There are three things you can do. You can either do this JSON trick, which is great in the sense that I would hate it. I would hate myself if I had to write this down. Another option is to like decompose the actual arguments of this thing, this object, and be like append name, append title, append blah blah blah, and. But it falls apart when you have a list. If you have like something that's like a 4-element list, serializable would be able to handle this, but like with this, then you end up like, okay, how do I serialize a list? And then you actually invent JSON. So at that point, you end up sending JSON. And what was the last one? I'm not even sure. Oh yeah, like you can actually do there are some options. Like you can like reach into your old pocket of tricks and save it into shared preferences and load it from shared preferences like a champ. This is what people have been fighting to avoid for years, and we are going to get back there because sometimes the ID is just not enough. You want a copy of this thing and you don't want it to update. And instead what you have is that, okay, so this is one thing, that parseables and serializables and enums as enums are no longer supported. But it gets worse. It gets so much worse. Because this is just one thing. This is clear functionality loss. And I had an argument on Medium with some guy who was saying that, but the documentation says that it's supported. I'm like, read the code. It's not. It's never gonna be supported. It's intentionally not supported. So let's see what people will think when they realize that it is intentionally not supported. Because you often hear this. They often tell you, it's alpha, it will be added. It will not be added ever.
So you're not a fan of not being able to send parcelable objects?
There are times when it's extremely convenient in the sense that it's exactly what I need, and now you cannot do it without serializing to JSON and then escaping it.
And the problem from just getting it from the database again is that it's then asynchronous and needs a moment.
Yes,
right?
it's asynchronous. So now you need to consider that it takes time, and sometimes you don't have that time. That's why you want to send a copy. In some cases, you want to send the copy, initialize it, and still load it from the database afterwards. This is something you can do sometimes.
Yeah, an edit screen usually, right? Where you on an edit screen, when you type something in, you don't want live updates because you don't want to change what you typed already in because the database changed. At least I think so.
Yeah, that's the simple way to solve that issue. Navigation Compose, this is just one thing. This is just extremely clear functionality loss. You had this ability. It was type safe, kind of. Well, it was you needed ProGuard rules to make it work in production, but it was still possible. Now it's no longer possible, but that's not my major issue with Navigation Compose.
Just one thing, if people want to see what we have been talking about, then they can watch on YouTube my MVVM To-Do List tutorial, because there we do exactly that. If I remember correctly, we send over a parsable object to an edit screen so that we synchronously get the data that we want to edit, and we don't have to go into the database and look it up from the ID again. Just so if people want to check it out, I will put a link to this tutorial into the show notes.
Yeah, because you can actually pass this parsable object, use it as initial parameters for your save state handle, get live data, and then you pass it to this initial string from this object you got as arguments, for example, and then you don't need to care about it anymore because it's initialized correctly, and afterwards you will still not have it overridden from the database. And this is sometimes what you want. Yes. But Navigation Compose, it has a significantly bigger problem than that, which is having to pass strings to navigate to a destination. And you manually need to define this URL string, and then you have to remember what the parameters are, what they are called. And the interesting thing is that when you're passing them in, you have to convert them to string, but you also configure it so that when they want to extract it into a bundle, which is not a type safe thing, it's a dynamically typed map, right? And you need to know what they are extracting the string as when you are retrieving it. So you define that, okay, so when I pass you this string...
You mean this long type and this...
Yeah, the long type, int type,
yeah.
nav type, stuff like that. They're used to parcelable type, but it explodes with an exception, as we know. So that thing, yes, you technically instruct Navigation Compose as to how it should decipher this string that you concatenated together and this particular argument in the string, so that they can put it into yet another not type safe thing called a bundle. So unlike in the case of multi-activity navigation, even though I like single activity and all that, even in the world of multi-activity navigation, when you had these new intent functions where you had to pass in the arguments as like string, int, all that, you could bundle.putString and you put in the string, it was expecting a string. You were not able to pass in a string as an int and vice versa. You had to pass it in with the right type. This is no longer the case. You need to serialize to string and you need to hope for the best. And it's amazing because if your string... Okay, I need to add this to this line, because if your string has an AND symbol and you forget to URL encode it, then it's gonna break your parameter deserialization within navigation. you manually need to remember that the string concatenation that you do, everything needs to be URL encoded because this is a URL. If it had an amp, like an AND symbol, it breaks your parameters. Okay? It's madness that this is something you need to care about.
And this will crash your app if you define these arguments wrongly with the wrong type.
Well, it will either crash or like half of the string will go missing and...
But I mean, if you pass the wrong of these type, I don't know how to call them, these long type and int type, these arguments that define the type of the argument, you can just pass the wrong one and it will compile, but then later crash. Is that correct?
Well, yeah. Like you would concatenate a long as a string, but you defined it as int type, so you want to get it with getInt, and it would explode at runtime saying that this is bigger than int max.
Yeah, I think I had the problem that I wanted to pass. I changed the ID of my objects from ID to long, and I think then it also crashed because I extracted
because
it as
it was
an int.
no longer an int, it was a long.
Yeah, right.
This is what it means, that this is not type safe at all. This is the opposite of type safe. Like, safearse was better. Like, safearse had problems. This is worse.
Yeah, I found safearse nice, but I think I don't use it as advanced and as elaborately as you did. Because for me it worked pretty well in fragments. Because yeah, we had these generated methods, right, where the arguments had the correct type that it expected. And this gave you compile time safety.
Well, it kinda did, right? Because your string keys had to match and the types had to match on both the sender and the receiver side. So it was kinda compile time safe. But
Yeah, just one more time I want to mention, if people want to see this in action as well, again, this is covered in my MVVM To-Do List. There we use the SafeArgs plugin, just so people have something they can take a look at.
Yeah. So this is actually interesting that you said that you didn't use it in such advanced ways as I did. I use Jetpack navigation in sample code to like show what it looks like, but when we have the opportunity to like decide what tech stack to use, we use simple stack instead of Jetpack navigation, because in simple stack you don't have any of these problems, any of them.
Simple Stack, by the way, is the navigation library you wrote, just so people know what you're talking about. And I will put a link to this into the show notes as well. Yeah, this is what I was going to ask next. For you to talk a bit more about Simple Stack and why do you think it's better than Jetpack navigation?
Yeah, there are quite a few reasons. Although better, like it's starting to offer a different feature set in a way, because Jetpack navigation with 2.4.0 started adding new things that like 2.3.0 really didn't have. Up to that point, like 2.3.0, we are basically offering the same set of functionality. With 2.4.0, they went a bit ahead and they have this save state, restore state parameter for multiple backstacks. I don't have something like that. There is a sample for how you would do multiple backstacks, but you would need multiple backstacks for it. It's not like one thing that works with magic and then you hope for the back behavior to be exactly what you want. Back on track as to what the key difference is. In simple stack, the way we use it anyway, and how it was intended to be used anyway, is that there are these classes that are called key classes. They define the screen that will be shown on the screen. This is abstract because it doesn't care if it's a view or a fragment or a composable. It really doesn't care. It cannot be an activity because activities don't share a context in any way. They are completely separate islands. So within an activity, you would be able to use this backstack class. And with that, you would be like, okay, so there's this new screen. What do I need to do to be able to render this new screen? And for that, Simple Stack offers some nice defaults, like the default fragment state changer, which assumes that you want to show fragments, like all your screens are fragments. And in that case, it ends up so that when you want to pass arguments to a class, like a fragment, I think, in this case, you have a parcelable data class. You annotate it with parcelize. You have all these properties. It just says, when this key exists and it's the topmost, so if this key is showing, then this is the fragment that has to be showing. That's basically all it says. And the way this works is that instantiate fragment equals fragment constructor. That's practically all you need to do, and the fragment will magically work. And for that, the way it's set up is that the fragment will receive this key class containing every parameter within this parseable argument, this parseable class, as an object that you can retrieve. So the way this works is that you get the key and everything is in it, like string, int, all that stuff. You don't need to care about any of it. You get it in a type safe way. You say backstack.goto key class, like for example detail key, and for example you pass it an ID or the object, because it supports parseable objects as well. It supports anything that parseable supports, right? So you pass it in, and on the other side you just get this key with a function called getKey. You get it in a typed way. So this is the only thing you have to remember. Like if you want to show this fragment with, like, I don't know, detail key, then you have to say getKey type detail key, and you get it as this detail key. And any argument that's in this key will be readily available. You don't need to deserialize anything because parseable already does that for you. So it's completely type safe. You don't need to type XML. You don't need to manage keys, string keys, have to manage it in such a way that it matches exactly what I needed in the XML and in the safe state handle, which also needed the exact same string key as you defined in safeargs. None of that is happening in this case. There are no string keys involved. You just get the class typed with all the arguments that you sent. You don't need to think about it at all. It just works. So that's one thing. And I focused on this one primarily because we talked so much about argument passing because of Navigation Compose. I really do think that people should be mad about it, or at least they should not accept that you need to string concatenate just because the web does this. Like, this is a native Android app. We have a typed language. We should be able to use types when you're talking to a screen. Anyway, so simple stack. I did mention this safe state handle requiring the exact string key, right? Like, the thing that simple stack also does, I tend to say that Jetpack ViewModel or equivalent. And it's because simple stack allows you to define that if this key exists, then I want this model class that I call scoped services to exist. So that means that you call this constructor, you say that when this screen is showing, I expect this to be there, and this is how you create it. So if you check for sample code, it makes much more sense than the way I'm talking about it, because for me, I see it in front of me because I wrote it a while ago. But
where can people find that sample code on your GitHub?
On my GitHub, yes. I think I will just give you some links.
Yeah,
and
I will put them all into the description.
Yeah, just to have one for Compose and for fragments, because the one that I really like as a sample is called the FTUE sample, the first time user experience sample.
You also have a YouTube video where you give a presentation and explain all these details, right?
Yes, there's a full talk about it. There's a talk about it, explaining it with multi-activity, fragments, multi-activity, Jetpack navigation, and fragments back in the day.
I will link that as well.
And simple stack, of course. And with simple stack, I show that just how simple it can be. But what matters here, though, is that so you have these scope services, and it can receive the key as an argument as it is created, right? So the reason why this is important to us is that there's no safe state handle where I have to remember the string key to get the right argument from a map. I just get the argument. It's that simple. So what you end up doing here is that you can use the key to get the initial parameters into your live data and stuff. And unlike safe state handle.get live data, you have to type a bit more code, because get live data internally saves stuff and restores stuff for you. Well, in the case of simple stack, you implement this interface called bundleable and you return a bundle, a state bundle, but it's practically a bundle. You return a bundle with all the stuff in it, and then you restore it. And the restoration would be manual in this regard. It's not like save state handle get live data, which tries to save it for you, and you hope for the best. And if it didn't work, then you have to set a save state provider. In this case, you do any conversion into bundle, and you restore it from bundle. And this is where I've had someone ask me once, so does that mean that you save and restore every parameter like a peasant? And I was like, yes, because I control it. I can actually define this object to be a byte array if I need it to, instead of having to like set a save state provider, which I haven't really seen anyone use, even though you sometimes need it. Yeah, so that's a thing. So the scoped services match the lifecycle of ViewModels. They are basically the same thing. And you even have something like ViewModel.onCleared. It's called onServiceUnregistered. It's a completely optional callback. Something that's a major benefit in SimpleStack in this regard. There are two major benefits here compared to ViewModels. One of them is that all of these callbacks are optional. Like you implement the interface and then SimpleStack will call it. And you don't need to extend from ViewModel because it's expected that you have onCleared always, even though you don't need it. And then you inherit this bag of internal objects that they use to create ViewModel scope and stuff. You don't have that because you just have a class. You just create a class and that's what it is. There's no magic. You literally don't have any structural constraints imposed upon you. It's just a model class that will exist across config changes. You don't need to care about this at all. And the other primary benefit that Jetpack ViewModel will never be able to do, it's not even able to do it with Hilt, is what I call scope inheritance, which means that in the case of SimpleStack, there are two scoping mechanisms. The talk explains it. There's implicit scopes and explicit scopes. Explicit scope was written later because we needed it, and then we realized that this is actually a really good idea. So the way it works is that you can define that this screen has an associated scope, and this scope exists if this screen is in the backstack, right? But what if there's a flow where you have 4 steps and some of them are optional, right? So in that case, one of these will be missing. And you're like, hey, hold on a second, we didn't take that into account. We expected this to be here, but it's not. So in that case, we have explicit parent scopes, as I call it. This is the other scoping mechanism, which says that if any of these screens exist in the backstack, then the shared parent scope of theirs will be created for them if any of them exist in the backstack. And this allows you to create some really nice stuff. This basically means that you have a flow of 5 steps, for example. If any of them exists, then this is kept alive for you. Its state is managed for you, like persist and restore, like across process that. And you don't need to think about it. In this case, you have to only think about how they need to return the same string tag to say that this is the scope that needs to exist. But I found that returning the fully qualified name of the object that you expect to be created in this shape and form, that is technically completely reasonable. Like that doesn't change it. It's shared. So, and one time I did it in such a way that I defined an interface. Each of them inherited this interface. It said that, I don't know, let's say edit profile flow key. That was the interface name, and what it just defined is that it expects the shared model to exist. And then the shared model exists between these 4 screens. And this is basically what you do with nested nav graphs and nav graph scoped view models in Jetpack navigation. But the reason why this is interesting in the case of SimpleStack is that if a screen has its own scope, then it can just say, look up this shared model and then have a reference to it at construction time. And then you can directly talk to the parent scope. Like you can talk to the shared model from a view model. So you can encapsulate view models in another view model that are within a shared parent scope. This concept does not exist in Hilt. It does not exist in Hilt at all. And with Jetpack ViewModel, you can only do it if you have inline factories and you create one of them and you pass in the other one to the inline factory, and nobody does that. Nobody does.
What does scope mean in this regard? It means a place where you can instantiate your view model and keep it alive.
Practically, yes. That's basically what it is. Like, view model itself, it really just represents the scope that is bound to a screen and is kept alive across configuration changes. And this is the same concept. So if you want to go into the nitty-gritty details, as they call them, it's basically a map string any. Like, that's what it is. That's what the scope really is internally. And you can put anything there, like, because you have... okay, so you say add and you give it this object, and the default string tag that is used is the fully qualified name. So as such, within this, you can add it that way, you can look it up that way, and if it exists anywhere in the scope tree, you can find it. Where was I going with this? So the scope really is just a way to store your objects and make it managed by simple stack, so that you get these callbacks. The bundleable, which I mentioned, which means that any of these scoped services, as I call them, but they are kind of like view models really, so that any of them can save their own state. You can implement scoped services registered, which tracks that this thing was created and this thing was destroyed. This is what I said is similar to onCleared. And there's also activated, which is that this is part of the scope chain that is the topmost, so the one that is currently showing. And one that I'm kind of proud of, but it kind of breaks with Compose's backhandler because, I don't know, backpress dispatcher is a nightmare. Is scope services handles back. So what you were able to define is that in your view model, you want to intercept backpresses. And you can return a Boolean as to return true if you did handle it, return false if you didn't handle it. So what people used to struggle with is, how do I make it so that my view model is the thing that triggers whether I intercept it back and just modify something in my state that is rendered on the screen, instead of having to go through the fragment to do it and then pass it to the view model, and then the view model processes back and then tells the fragment if it did something, and then suddenly you realize that with backpress dispatchers you cannot actually do this because you have to know ahead of time if you want to handle backs or not. And this is why I really don't like backpress dispatcher. I think it's not a good API. But what's important here is that your view model can intercept back. You don't need to go to the fragment to do it. You can do anything with that. And this, as I said, it goes through the scope chain. So that means that either the screens or any shared explicit parents that exist, if any of them are handles back, then it's asked, hey, do you want to handle this? And they're like, nope. And then it goes up. And so you can intercept back at any level. And that's really useful, actually.
That's another benefit of
Simple
stack over navigation library.
And view model, because this is practically a replacement of view model in a sense. This is why when people talk about it, I'm like, I use something equivalent but not view model. This is why, because and there's one major benefit, of course, because I did tell you that you don't need to like extend or inherit from anything. You just create a totally normal Pojo class. The reason why this is important is that the ViewModel factory, it expects a class that is a subclass of ViewModel, and then it returns something, right? That's how it works. But as such, you cannot say that I want a ViewModel that implements this interface, and then you never see the exact type of the ViewModel. You cannot swap that out. You are forced to see the exact type of the ViewModel. And as such, you cannot have a separation where you would be like, my view expects the implementation of an interface that is implemented by this view model and then not see the view model itself. You cannot swap that out. But with simple stack, you can definitely say that I added this model class and I also bound it. I added this alias for it, as the internals say. So I bound it as an interface so that when it's looked up as this interface, then it will be found as this interface. And then the view actually has no idea who the view model is or where it's coming from. The only thing it knows is that I have an interface that I defined, that someone can handle my actions and someone can give me data. And if you think about it that way, that's very Compose-like, isn't it? That you get these arguments through an interface, but you don't know the exact type. You don't see the view model. And in a way, I feel like this is why people are still passing view model in so deep into the composable hierarchy, because they are not used to this ability of being to separate your view model from your fragment. Yeah, so as such, what it really did offer is seamless type-safe navigation. You literally just say backstack go to something and it just goes there. It works immediately. You never run into issues. You had these scoped services that are super powerful. They have safe state persistence at any level without something like a safe state handle. So you don't need to micromanage string keys that are defined elsewhere. You do need to use string keys when you want to save into the bundle and restore from the bundle, but that's local to this class, so you don't mess it up. You can't mess it up. You can't have it like someone in the navigation file changed this string and now I get nulls in my code. That doesn't happen at all. That's impossible. You also get these really nice callbacks to define whether this thing exists or not. You get this backhandling in a view model. You can actually get the backstack reference in a view model. So instead of what you did originally with how you would channel down your events from the view model into the fragment or the composable with the disposable effect and then pass it to the nav controller, you just see the backstack directly in the view model and you can call functions on it and it just works. You don't need to... Simple Stack already handles that the view is being recreated in the background and should only show the new view when the new view is available after a config change. This is all handled for you. You don't need to care about it. You just call the function in the view model and it navigates for you. Imagine that, because that's something that people, I think, forgot about. Like, remember how you had this live data of event T of navigate to detail screen and then you set it on the live data and then you use this event observer in the fragment. None of that is needed. You just call one function.
I'm actually still doing that, not with the live data event wrapper, but with flows, with a channel.
Yeah, and then you would need the disposable effect and channel in this case, yes, and you collect the flow in the composable so that
Launched
you actually
effect,
have a
I think.
reference to the...
Launch effect, because we need the coroutine. Yeah, doesn't matter.
Same thing as remember coroutine scope and using a disposable effect and using launch, which is what I tend to do. This is something I asked on Discord, the Android Dev Discord. Am I the only one who does this? And they're like, yes. And I'm like, okay. And it makes perfect sense. Theoretically, this is what launch effect does internally. But yeah, so you collect this channel in a launch effect, and then you have a reference to the nav controller, and then you navigate. But what you really want it to do is just
navigate from the view model.
Navigate from the view model, and with simple stack you get the backstack and you just call the function and you navigate it. You don't need to do any channel, any effect, anything at all. It just works. So that's also a benefit.
Yeah, this was a summary of simple stack again, right? And
yes,
I think you didn't mention the scopes in your summary. I think
I didn't. Oh yeah,
maybe
yeah, like these scoped services, these view models that I mentioned as view models, they technically, and that you can easily, like, you just return the string key and you end up with this shared model between screens, but subscope compared to like the activity, but it's a super scope to fragments. So it's like this scope in between the screens. And this is something that people wanted to solve for a very long time. Navigation, like nested navigation and navigation graphs, are technically one solution. This one is another. But in this case, in my case, you can inherit from the parent scope and talk to the parent scope without having to, like, I don't even know how you would do it with fragments, to be honest. You would just see both of them, maybe? I'm not sure. Like, they can directly talk to each other. The child can talk to the parent. And this way, you can actually destructure view models. You don't end up with this one that's like 500, because you can pass a view model to a view model. This is a thing you can do with simple stack.
Wait, so I can talk from a smaller scoped view model to a larger one?
Yes. Yes.
Because this was a problem I had, that this wasn't really possible. And then what
With
I
simple
ended
stack,
up
this is immediately
what I ended
supported. You
up
don't need to do
doing
anything.
was usually going over application scoped singleton or something like that. Or maybe
Oh,
not
geez.
application scoped, but through a singleton that's behind the view model, basically. I tried to come up with an example where I wanted to talk from a smaller view model to a larger one, but with the normal navigation library, it's not possible, right? So I use a
It
singleton.
happens if you have a multi-screen flow. That's when it happens. Like if you have like this flow that takes like 4 different screens, and on like one of them you have I don't know, you have this search and stuff, but you still need to mutate some user input in a shared state, but you want to discard it if you navigate away, like you cancel this flow entirely, then you just don't want to have it in a singleton. What you can do if you want to survive across 4-stop and attributes, of course, is save everything to a database or data store or shared pref if you really don't like yourself. But you don't always need that.
Yeah, I think in my example, I was actually trying to talk from a smaller view model to an activity scoped view model. This is why I ended up with a application scoped singleton, because that's the lifecycle of the activity in a single activity app, right?
Yep. Funny thing actually with simple stack, there's the concept of global services, which is like the parent scope of all services, and it matches the same scope as the activity scoped view models. And you can talk to them with just saying lookup when you create the view model for the screen, and you get a reference to it, and you can just talk to it. Imagine that. You can actually just call a function and you get the reference, and it just works. You don't need to care about it because it just works. This is something you can do, and it's easy.
Yeah, nice. So people should check out SimpleStack. And I don't know if I missed that, but does it work with Compose or only with fragments?
Oh, I didn't. Well, I did mention that Backstack, the core itself, like SimpleStack's core as it is, it doesn't know about any of it. Like the only thing it knows about that's Android specific is parcelable. Like that's the only thing it really cares about. Like it has code to support view-based navigation. I haven't used that in a while, but that's there. But you will probably not use that. The way it works is that you have these key classes that I mentioned earlier that contain all the arguments and describe what screen should be showing. And how that is shown is totally up to you, which means that I offer defaults for how I typically use fragments and have been using fragments for the last 5 years. And on the other hand, there's also another repository called SimpleStack Compose Integration, which I consider to be slightly experimental, but not as experimental as Navigation Compose, which is able to render composables for you as the building blocks of the app, like no fragments involved, just composables, switching between them. And it actually has a slide animation by default. Like if you go forward, then it slides in. If you go back, then it slides out, which is fascinating because how long has it been that Navigation Compose didn't support that? 8 months, I think? I had this working 8 months ago, guys. This was actually working 8 months ago. So on the other hand, they had to rewrite the entire internals of Jetpack navigation to support the idea that navigation is not just a command that you execute once and then something will handle it, but they actually need to track that the state exists and there's an in-progress state while 2 things exist at the same time, and one of them has to be rendered as it is navigated out, and that ends and it's an asynchronous process. The backstack in SimpleStack was already assuming that it's something that is an in-progress process that will be executed eventually. It's generally hidden from you because the default fragment version, it uses a synchronous call. I mean, synchronous call, not asynchronous call. And but with Compose, this was super easy. For Jetpack navigation, they had to rework the internals. and it's actually fascinating because that's something that's been happening like in the past 2 months, I think, maybe more. Because without that, you cannot navigate between 2 composables and animate their changes. They have to both exist at the same time. And you need to track that one of them stopped existing. Anyway, so back on track. Yes, there is a simple stack compose integration, and something that someone asked is, am I making a composified version of simple stack, which would mean that simple stack would be purely compose only and would only support compose, but still have all the things the simple stack does. And this was not a priority for me, and it was not a priority for me because as we use Compose, I primarily consider it a rendering framework. Like, I know that you can store state in it. It has the saver framework. You can use remember savable. You can manage anything. And if there was a backstack that was like a composable backstack, for example, then you would be able to nest them indefinitely. But my problem with that approach, and the reason why I'm not doing this, is because once you have 3 levels of nesting with these backstacks, then which one do you want to talk to? How do you know which one you care about, right? Like, currently there's one backstack and it manages the top level scopes, and it's basically exactly how Jetpack navigation works as well. They also have one nav controller, as you know, in the nav host fragment. And while you were able to nest them, you typically didn't, because then the which nav controller owns what scope, and those nav controllers definitely won't know about each other and ask the parent, hey parent nav controller, do you have this scope, because I have no idea. They don't have inheritance. For me, I would have to ask the parent, and then I have to define what does it mean to be a child backstack and all that. And it's all possible, but I haven't found it to be necessary. And as such, I don't really see a reason to like connect simple stacks internals to be based on Compose, because it doesn't really offer me much. I just need to navigate from one screen to the other and render the changes. And as long as that's what I need, one global backstack works pretty well.
And you already briefly talked about the pure Compose app without fragments, but I know that you've always been a proponent of single activity apps, right? So a second activity is usually not necessary at all. What about, for example, if someone has a login activity or something like that? Is that unnecessary or can it be useful?
It's unnecessary. Yeah. You should have a login fragment.
And why is it bad? What problems causes this?
Okay, so when you have 2 activities on the task stack at the same time, that's when you need to start considering the interaction of activities that are on the task stack within your own same task, right? So that's when you end up with having to care about, I returned on the second activity, there's an activity behind me that is dead but will be recreated as I navigate back to it, and intent flags that if I have 3 activities and I want to clear off 2 of them, then how do I do it? Well, with intent flags, okay, but what launch mode do I need? Single top, but I need 2 of these instances. Well, you cannot do that at the same time. Okay, do I need to use start activity for result chains, which now would be deprecated? Amazing. So would I need start activity for result chains forward so that I can finish 2 activities to navigate back twice instead of just once and then once? And then you're like, yes, you do need start activity for result chains to navigate multiple times. So when you have multiple activities, you suddenly need to care about these things that some Android developers probably take for granted for this point. They're like, this is how we've always been doing it. So why would you consider this a problem? And you're right, you can make intent flags work. Just ask anyone who uses intent flags and how much they like it and how predictable they find it. Because usually it doesn't work. You need to like end together things. And it's funny because there's this one more thing that people like to do, which is to like once you logged in and you had a register screen and you had another screen and you had another screen and you had these 5 screens at this point, right? Like you have these 5 activities on the stack. Obviously this isn't the case when you have a login an authentication activity and you have fragments in that, and then this is the only activity at a time. But if you were using multiple activities, then what people tend to do is at the end they're like clear task, new task, and not only does that make the animation super wonky, it's like boom, it throws everything out and everything comes in, and the app just looks super weird as it does that. Instead of just like have a transition or crossfade or something that you're used to, it just like throw stuff around. It was fascinating. There was this Google sample that did this to like navigate between navigation drawer screens. What they did is that they both were each an activity, and they killed the current one not with finish but with this clear task, new task, and it was each time you pressed the nav drawer, it was like whom, whom, just throw everything out of the screen as the new screen comes in. And they fixed it eventually, but it looks super bad. So where was I? Oh yeah, multiple activities at first. So why does having a second login activity cause trouble? And the reason for that is because of the way the launcher interactions work. Like there was this very specific bug that we ran into, which was that we had a splash activity and a main activity. We had a separate splash activity, and that caused us problems, okay? That alone caused us problems because that one was a default launch mode. The other one was single instance launch mode, I think. Yeah, single instance. And the way it worked is that after process that, it would, for whatever reason, launch the splash activity from the launcher. I don't know why, this typically never happens. But when it loaded the main activity, it called on new intent. And I'm like, where have you been? Like, why is new intent being called as I navigate to this screen, right? Like, you get these super crazy things sometimes that you just cannot even predict. And on new intent was bugged, and that's obviously not the problem of the activity framework, but that we inherited code that didn't work, which was originally like clean architecture based and modularized in ways that you don't want to know about. You probably want to know about it. We should talk about it. But what matters is that broke things. So like the way, once you have a second activity at all, it changes the way your app behaves. And you need to care about so many more things. In fact, if you have singletons that are stateful, then you have to use a base activity to like save and restore that singleton state, but only once, right? So you have this static flag, and in the base activity you restore it once, and then you have to care about having to extend from that base activity in all of your activities, stuff like that. So yeah, the moment you have a second activity, you need to care about things. You need to care about how things are no longer shared between one context. It is shared between two contexts, and you will probably do that with a base activity. And then your base activity will grow indefinitely.
So people should always have a single activity.
Yeah, I think even for a splash screen, if you have one, I would just throw that into one activity. If you have one activity, you don't need to care about the activity lifecycle and its interactions. You only need to care about on stop, meaning that you are either rotated or that the F was put in background. It doesn't trigger across navigation, right? Like you don't trigger OS level lifecycle callbacks with your own app standard behavior. There's just so much weight removed from you just by not having to ever care about this.
Yeah, I remember, I think the main reason for me why I wanted to have a second activity usually was because with the navigation fragment library, it was difficult to have a bottom navigation bar on some screens, but not on others. So the easiest way was to just create a different activity for example, a login screen that doesn't have the bottom navigation. But with Compose, this is actually removing the bottom bar actually works now. So I guess this is less of a problem now.
I have an even better answer for this though, which is that you definitely didn't need a second activity for that. The bottom navigation can be put into a fragment, and then that would manage child fragments, and it works.
But this won't work with the navigation library, will it?
It does. I have a sample. I have a Medium article and a sample.
But it sounds complicated.
It's not that complicated. It was actually easier than with simple stack, and I was like, what the heck? Why does this work?
But with Compose, hiding the bottom navigation bar is actually, or at least for me, it works now. But the problem is I can't have animations between these different bottom navigation destinations, because then you see the difference between the fading animation between the screens and the bottom bar actually hiding. So this happens a moment later, and then you get a really ugly effect where the screen size suddenly changes. So the only way for me to get around this at the moment was to completely remove the the animations between the bottom of items, and for this I needed the Accompanist library, because otherwise you couldn't remove the animations that are there by default in the newer Compose versions.
Yeah, the crossfade, the non-configurable crossfade, which is the only stable part of the animation APIs that are like nicer than just animating the float from 0 to 1 and doing whatever with modifiers, which is what I do, by the way. Animate the float from 0 to 1 and then use modifier offset to push things off the screen and on the screen. Yeah, Accompanist, that's also a fun topic. But people need to know about it. It's an incubator project. There's a reason why it's not an official Jetpack library. That thing will be tech debt the moment you add it to your code. You will be removing it later. That's why it's made. That's why it's not a Jetpack Compose thing. Its existence, its very goal in life is to be deprecated later. Okay? So think about that for a moment when you pull it in. That's why we created a Compose app. We do not use Accompanist. We copied out Flowrow because Flowrow is nice. But that's the only thing that we used from Accompanist. And we didn't pull in Accompanist for it. We just copied Flowrow.
Yeah, I use Flowrow too, but I didn't copy it. I used it from the library. That's the composable where it actually breaks into a second line when the screen becomes too small, right? Where you have composables next to each other, and when the screen becomes small, they will move to the next line.
Yeah, it's super convenient. And once I read the code, I was like, I'm not writing this myself. So I was like, just copy paste.
But what I was getting at was, but you told me that a pure Compose app is still not realistic in the real life.
It is possible. I would definitely advise against it.
Why would you need still fragments?
I would use fragments because, or three reasons. One is that existing integrations with other libraries and SDKs and existing code. Like, unless they are like, okay, we support Jetpack Compose and we expect to be called from something that doesn't exist, or it is called multiple times but doesn't actually exist as a thing, then yeah, sure. But on the other hand, it's quite unlikely. So like, if you had to like call into an SDK that exposes a fragment, how do you do that from composable, right? What you need to do then is like go from the activity, because that's the only thing that can talk to a fragment, call the functions on that, and then dispatch it back to your composable. And for that, you would use like an activity scoped ViewModel channel, for example, and you collect it from a composable. And I was gonna say you would observe it from like the ViewModel, but as you know, you cannot pass an activity scope ViewModel to a navpack stack entry scope ViewModel. So you would observe this activity scope ViewModel from a launch defect in a composable and get it that way. And you would not need this if you had a fragment that can just call start activity for result, and then you get the result right there and then, and process that shenanigans, like you going to the other activity and your activity dying and then coming back. You would actually get the get on activity result in the fragment when that is done and the fragment is recreated. These are all things that the system was doing for you when you were using fragments, like process that restoration of a nested child hierarchy, and then waiting for these events to be given to you only when that was available. These are all things you can do, but seeing that I don't think this is something that beginners like to do themselves, if that makes sense. Like, it's not hard, but you need the right tools. And for example, I use event emitter. Most people use channels. That works. But if you don't know that I need a channel dispatch from this activity scope ViewModel la-di-da, then who will do this for you? And the answer, of course, that is Accompanist has a function for it. And I told you to like Accompanist.
So what would you recommend? Would you recommend that people put composables inside fragments?
Compose view in a fragment. That's what we did, and it works. It works perfectly fine. In fact, it makes you not have to think about, okay, how do I make this happen in Compose? Because, well, this is a pure Compose app. How does it even work? Like, this doesn't happen because it's just fragments, and the rendering is done by Compose, but you still have fragment navigation. Oh yeah, fragment navigation for that. Number 2 reason. The reason why you really want fragments, even if you don't use simple stack, then you would still keep Jetpack navigation and safe arcs and all that, which worked and didn't require you to serialize to a string and then configure a string deserialization into a bundle, so like triple the lack of type safety. Navigation XML was better than this. Like, and if you want to keep it that way, you want to keep like this XML, this preview that you get, for example, which I had no use for because nested nav graphs are not rendered. It just says nested nav graph and that's it. Like, that's not helping me at all. Oh well. So to get the preview and the safe arcs and like just more stability in the sense that you actually have transitions and not just one pre-configured crossfade that you cannot even disable without pulling in Accompanist again, where we clearly know that this is an incubation process there. They only have it in Accompanist because the animations in Compose, most of them are still experimental, and Jetpack navigation does not want to depend on experimental things because it can't, because that would break guarantees if in Compose anything changes in this regard. Which also brings us to that you probably shouldn't depend on libraries that use experimental Compose functions. Yeah, that's quite important. But back on track. So why would you still need fragments? And the reason for that is that if you're still using the Jetpack ecosystem and not simple stack, then you need to care about how to get a view model that exists for the scope of this composable, exists still as you navigate forward from it, but this composable dies, like it's no longer there, so why would it exist? So you navigate forward, but you want this view model to exist here, back in the back, right? So in this case, who will track this state for you? Who will track this view model? And the answer for that, given by the Google team, is Navigation Compose, right? That's why they have the nav backstack entries, so that you can navigate away from a screen and the view model store would still exist because it belongs to the nav backstack entry, and the nav backstack entry is kept alive by the nav controller, and the nav controller is kept alive as a, well, inside the view model, therefore as a non-config instance, right? So as such, these view models stay alive even as you navigate forward, but they are cleared and destroyed if you navigate back, right? This is managed for you by Navigation Compose, and unless you want to write this by hand, you will end up using Navigation Compose, and you don't really want to use Navigation Compose because it's not type safe at all. It has extremely intrusive effects on the way you call navigation at all anywhere in your code. So if you were using actions are obsolete now. If you were using anim tags, for example, in the Kotlin DSL, that's obsolete now. If you were using parsable arguments, well, tough luck, that's no longer supported. So what you have left is having to string concatenate anywhere and everywhere in your code and throwing out existing well-working code because it's a completely different world with less features and less stability and less predictability and less reliability overall. And also it has this crossfade. So like I was just testing it out, just see how it works. And I was using Hilt against the navgraph scope ViewModel. I was getting so many crashes, man. I had like 3 different crashes. I had to fix it in such wonky ways you don't even know. Like, man, I have a sample for that as well. And there's a bunch of these comments saying that I need to do this because otherwise it crashes. My favorite one was that having a composable on the same level as a navigation tag, instead of like navigation, and composable, that would crash. It crashes if the composable is the first composable and it navigates the nested nav graph. It used to crash. They might have fixed this since then. But that was also fun. And I was like, why does this crash? This should work. And then you add this navigation tag, hoping for the best, and it works. And you're like, I don't know if I should be happy or disappointed. Like, what is this? Of course, that was still with alpha, but I think Navigation Compose is still alpha. Where was I? Fragments. We were talking about fragments. So one more thing as to why you would do it. Yeah, so Navigation Compose sets up the local view model store owner, the local safe state registry owner, and all that stuff. And if you use fragments and the compose view inside the fragment is already the local ViewModel store owner. It's already the local save state registry owner. You don't need to care about any of this, and you don't need to depend on navigation compose for these things to work. Fragments are already retained by the fragment manager. You already have the convenience of navigating forward and the fragment staying alive as you do that, and its ViewModel store staying alive as you do that. You don't need to depend on navigation compose to do it. Obviously, you can write the code that Navigation Compose is doing. They are not doing anything magical. They are an external library. They don't do anything that you cannot do by hand. But on the other hand, you probably don't want to write it. So yeah, as such, fragments are much more stable. You still have animations. You have somewhat type-safe argument support. With simple stack, you have fully type-safe argument support. You have integrations with existing libraries. You don't need something compose specific or Accompanist based or whatever. It just works like fragments as they have always worked. They still work. And I think that's practically it. You get a better, more refined lifecycle. You get on start, on stop when you expect. You get on save instance state and all that if you need it, which you probably won't. With Compose, you get remember savable, so that works. Yeah, so fragments already encapsulate this thing that nav backstack entries would be doing for you if you use Navigation Compose. But if you want to avoid Navigation Compose, then you probably still want fragments, because the other thing that people tend to do sometimes is create one activity scope ViewModel and pretend that this is going to work. Well, you authenticated and you logged in and now you logged out and you want to clear it, and now you have to manually clear it and stuff. You don't really want to put everything into an activity scope ViewModel, because that's effectively a singleton. And then when you say that, okay, then I'll just make a second activity, then you've effectively undone 4 years of Android architectural progress that we have finally made that Square was advocating for since 2014.
So basically, people should use ideally a simple stack and composables in fragments. But
composables in fragment, yeah.
But if I read it correctly, fragments are not as important in the Compose world if you actually use the navigation library, because it gives you this backstack entry.
Yeah, that's the intention anyway, for nav backstack entries to completely replace fragments. But for that, you need to depend on lifecycle owner based things, which is great. But if you are used to like on start, on stop, for example, and not writing your own default lifecycle observers, then that will still be harder for you, I think. So as such, I think fragments still offer a convenience in a sense, just by having these callbacks instead of having to know the specific way to do a specific thing. Some things are more readily available for you and easier to manage, I think.
Yeah, and you already mentioned process dev a couple times, but some people
Yes.
that watch this video might not even know what this is. Do you quickly want to summarize what process dev on Android is and why it's important and what happens if you ignore it?
Yeah, so process dev on Android is when you have an app, you go onto any screen you want, somewhere in the middle. Let's say you are on a detail screen coming from a list screen. And so you were on a detail screen, you put it in background, you take a picture of your food, you post it on Slack, you maybe even put it on Instagram, I don't know. You come back to your application and Android will have most likely, because of just the camera and Slack maybe, Android kills the process of your application to reclaim memory, because it's like, well, you're not being used, so why don't you give me my resources back? So it kills your process, but it saves the activity task records and whatever is stored there. So within the activity task records, they store the fragment state and they store anything that you return from on-save instance state. And this is what the saved instance state is when you have activity on create. This is what it is. So what happens then is that you come back to your application, and what happens is that it will be as if it had been running for the very first time, like it's never been executed before. Or your static variables, if you have any, or your singletons, they are nulled out. The application is recreated from scratch, but the activity task records are used to restore the activities and their state. So what happens is that you start the screen, the save instance state is not null, even though this is the very first execution of the app. And from there, you can restore it. So you end up on the detail screen. And as you navigate back, then this is the very first time that you have ever been on this list screen. It has never existed before during this execution of the process, right? So what you need to consider when writing an Android app is that no matter what screen you are on, it can potentially be the very first screen that executes in your app. It is the first screen, no matter where it is. And only what is saved either on disk or in the saved instance state is what will be kept alive. So anything that you put in a singleton or something floating in the air, that will be null. And if you don't restore it, nobody will, okay? So as such, you need to consider this. And this is where a lot of null pointer exceptions used to come from. That people were like, I don't want to use intents and fragment arguments. I can just set this static variable because I've always been on this screen. Because how else would I get to this other screen? But the answer to that is that, well, after process that other screen is the very first screen to have ever executed. The previous one never did. This is a new process. None of your variables exist anymore. None of your state exists, only what you saved.
So as an example, people can go to a detail screen in the app and they put the app in the background, open a camera or whatever, go back into the app, and then this detail screen could be the whole app could be recreated basically, but we start on the detail screen.
Yes.
And if you send a piece of data to this detail screen, like the ID from which you get the object itself, then if this is not properly stored, then this is lost and you basically don't have this information anymore. And then you have this detail screen open, but not an item that you can actually display. And I guess in best cases, it would just show an empty screen, I guess. In worst case, it would crash. Or is it
most likely crash?
Yeah, most likely crash.
So yeah, the solution to this problem though, or at least as it is intended, is to pass the ID as like either an intent extra or a fragment argument or as part of the root now with Navigation Compose.
Those are also sent again after process dev, those arguments.
The arguments are restored, like okay. They are part of the activity task record. So the two things that are restored as such, sorry, I said one earlier, but it's technically two things, the saved instance state and the arguments. So intents are restored, and other than that, the fragment arguments are managed by the fragment manager, so that is restored accordingly with that. So yeah, the application can restart anywhere. And some people might say, hold on a second, I can fix this problem super easily. I will just prevent Android from remembering everything and just always launch from the very first screen. And I'm sure this works to some degree in some cases, but not only is it a horrible UX, but imagine that you are within a login flow and this is real. It actually happened in a real app. I had to revise the navigation in that app because they were just discarding all states across process that. And there was a registration flow. And in that flow, you would get an email that would describe your verification code. And you would probably press home, go to Gmail, check your code. You went back and you want to input it. And I have seen process that happen in that short amount of time. Yeah. So if your process does not correctly manage this, then you will lose either the states from the previous screens because you either didn't pass them through an argument, or you don't have a shared model, a shared scope where your state is persisted and restored, as you would with NavGraph scope view models or with like the scoping mechanism in SimpleStack, as mentioned earlier. So this would be lost. This is one thing. But if you just throw out all the screens, then you got this email, you have this pending registration, and now you have to input your user email and your password again and go through the same loop. And unless you know that you can like use multi-window mode, assuming that the developers didn't say resizable activity false, you can enable multi-window mode and keep both the activities alive, like both apps alive.
Or another option is that you get the email and see it in your notification shade, but that's not always the case. It
Yeah,
depends on your
sometimes
email
it just
settings.
doesn't fit, so you want to click it. And then that alone was enough. Okay.
Yeah, I just want to clarify a few things. The system automatically opens the same screen we were on before and not the starting screen after process dev. This happens automatically, right? No matter if you used fragments or composables.
Yes.
So when you were on the detail screen and the process is destroyed, you open the app again, then we don't end up on the starting screen. Instead, we get to the same detail screen we were on before. Just that the information is lost if you didn't save it properly.
Yeah.
And also, people might think, but isn't this what the Jetpack ViewModel is for? But no, Jetpack ViewModels are also completely lost in the process dev. They only cover configuration changes and restore data when you, for example, rotate a device. But process dev, the ViewModel also completely loses its state. But first of all, is this actually still realistic on modern devices that have a lot of memory?
This thing has 4 gigabytes of RAM. I experience process that all the time.
Yeah, I think I
Yes.
do that too. I don't really pay attention to that. But one thing I notice is that I often have my fitness pal open where I track my food, and I put it in the background, and I often start again at the screen I didn't know. I don't know, at the top of the screen, I guess. But I don't know if this was related to process dev at all. But
It's possible.
But it still happens. And yeah, as you already said, these arguments, navigation arguments, are restored automatically. But the easiest way for me to usually get or usually store data across process dev is by using the saved state handle in the view model. So do you want to talk about that for a moment?
Oh, definitely, yes. So the save state handle is pretty much a necessity addition to ViewModel, because back in 2017 when ViewModel came out, they did not support any direct callbacks like on save state, on restore state, or this kind of thing in ViewModel, which I did think was a design oversight. But it took until 2020 January for the ViewModel save state integration to come out. So the way that works is that instead of a callback, you get this thing called a save state handle, which internally is a map of things. You set stuff on it, theoretically, and those things are going to be saved when saving needs to be done. So that's how save state handle is intended to work, or at least that's what you would assume based on set and get. But the real way to use the correct and intended way to use save state handle is to use this method called savestatehandle.getLiveData. And the way that works is that you pass it an initial argument, which it uses only for at initialization, and afterwards any changes you make to this live data will be saved in the background when saving needs to happen, but it will also be restored in this live data this way. And it's quite fascinating, really, because it's a mutable live data. So in each of these save state handle get live data, mutable live datas, anything you put into them will be saved across process dev. And this way, what you can end up with, due to the properties of live data and the power of mediator live data, is that if any of these properties change, which are used as the foundation of, like, for example, retrieving data from the database, like the current selected ID, the current search text inputted by the user, all that, this sort of stuff. This is all coming and connected to the save state handle. And after that, you can use this live data as a reactive source, so that you can either combine them with mediator live data. I have a library for that. We should totally add it to the description later. So you can combine them. You can also use switch map, and you can use like the coroutine live data, for example.
And you can turn that into flows.
You can also turn them into flows. That also works. And then use them as flows and then use combined with flows. All that stuff, that all works. So as such, you suddenly enabled yourself to reactive state management, while also making sure that the state that needs to be saved and restored is automatically saved and restored. So I think that's really cool, actually. And for some reason, I don't see it used as often as I would like. I especially didn't see it as much in Google sample code as I would have liked. They typically use get and set, but I think that's harder to keep in sync. So I would recommend using get live data.
Yeah, people have to understand that even if they want to get rid of live data and use flow between the view model and the UI layer instead, they still have to use this get live data method to store this flow in the saved state handle, right? So there's not really getting around this.
Yeah. Like I saw a trick where for each property that they want to get from the save state handle, they set up a flow that if they modify this mutable state flow, then it saves it with .set into the save state handle, and it uses the get for initialization. But for example, if someone were to call save state handle set with the same string key elsewhere, then they would not be notified of it. So using get live data is safer, and as such, as long as the save state handle doesn't offer an API that says get as state flow or get state flow or something like that, and you get live data, you will be stuck with live data if you use Jetpack ViewModel and you want behaviorally correct applications.
I usually turn them into flows, and then if I want to use a flow in the view model, then I just call get live data and then call sFlow on this result, and then it's a flow basically. But some people think that they can just put mutable state flows, or now with Compose just mutable state into their view models, and this is enough. But this probably means that your app will misbehave if you put it in the background for a while, earlier or later, because you're not handling process dev. Again, I show how get live data with the saved state handle works in the MVVM To-Do List example. Again, the link is in the description. And I also wanted to mention that you automatically get, when you use the navigation Jetpack library, then the navigation arguments are automatically put into this saved state handle in your view model. So this is also a really nice way to get a handle to these arguments without having to call a method from your fragment or composable on your view model first. So let's say you navigate to a detail screen and you send the ID of your object over that you want to show, then you can get this ID out of the saved state handle right inside your view model without having to extract it from the fragment or the composable first. And now that we talk about this, do you also have something similar for simple stack? Or is that not possible to do for an external library?
Well, hold on a second. You mean to have a save state handle for an external library that is not ViewModel?
No, I mean getting the navigation argument that you sent over out of your saved state handle.
Well, if you use simple stack, then you don't have a save state handle. You get a key, and and the key contains all the arguments, so you get them directly as such, and you can pass it to the class's constructor directly, and that's it.
Okay.
But yeah, it works with simple stack as well.
Is there anything to add about process dev, or did we cover it basically?
I think we practically covered it quickly, as fast as possible.
Yeah, it's good to talk about this because I know that there are many people still that have no clue about this, especially beginners.
Oh, there's one thing we could talk about on this regard, which is a quick thing that I saw, which is that some people argue that view models are no longer needed for Jetpack Compose, and that process that is no longer a problem in Compose. These are two things.
I think the initial creator of Jetpack Compose himself said that Jetpack view models are not really needed anymore, right? On Twitter.
Well, there's technically some truth to that and some not. Like, you can use remember saveable for sure to save state in Jetpack Compose across process that, and you can also use Android config changes orientation to block orientation changes, but to that I tend to say that you could have always done this. Like, if this was
that's not enough, right? There are other configuration changes, like changing the size of the text, I think is also a configuration change. This is also something people do. They just lock the orientation and they think they don't need to handle configuration changes, but this is just one of multiple different options.
Yeah, especially because of how multi-window mode is now becoming more and more normal, and that's also a config change, so you need to care about it.
Yeah, you can't ignore that.
Yeah. So as back to that view model not being needed, well, you kind of do and you don't. Like the concept of a model that is separate from your view representation exists. Like you can definitely have everything as remember savable inside a composable, but and you could also theoretically use like remember coroutine scope and even execute coroutines inside your composable itself. But that doesn't mean that that's good for your code structure over time. Like if everything is in Composely, if everything is like a UI representation, then we basically come back to something that's very similar to when activities used to do SQL operations in onCreate.
I thought what he meant was creating a normal Kotlin class as a view model instead, and not using the Jetpack view model.
I mean, you can do that. The question then becomes who will save and restore its state, right? Like if it's just a normal class and that doesn't have either a save state handle or isn't a simple stack managed class that implements bundleable, who will save its state?
Okay.
Like I guess you could put it in remember savable and hope for the best, but there are some properties that you do want to save, some that you don't. I guess you can extract that state. I think that's a rabbit hole in a sense. I think removing view model entirely, or at least the concept of a separate model that stores your data that is separate from your composables, I think it's early for that. I'm not so sure that that's a good idea, but this might be just bias talking.
And then I wanted to talk a bit about reactive programming because you are a fan of that.
Yep.
Maybe you want to say what it actually is, what are the benefits of it, and what is the alternative to reactive programming? So what did we do before this was invented, basically?
Okay, so what people used to do before they either recognized the thing that is called the observer pattern is that they had these mutable variables everywhere, but when something changed, they would also need to invoke some function right after it, right? Like they were like, I changed this method, and then it's like on text changed right after that, for example, which is, I guess it makes sense to some degree, like, but now you need to remember that each time you mutate this variable, you need to call this method that emits a change. Now you can say that, hold on a second, I can just extract this function and say that set text, and it would expose that this.text again equals text, and then notify observers. But now you have actually already invented observers. So what people used to do without the observer pattern is just have mutable variables randomly and then just mutate them randomly and read them randomly and end up with this 1600 lines of code with a bunch of checks for these booleans. Is this boolean still set this boolean, la-di-da. And what you end up with in the end is a bunch of callbacks in that, yeah, this updated, and then you end up with a lot of temporal coupling in your code actually. What this means is that when this happens, this also needs to happen, and it needs to happen in this order. That's what temporal coupling means. So without the observer pattern in this case, you would need to remember this coupling, that this needs to happen right after this one, and you manually need to notify this. And this is okay at first. You do it twice and you're like, wow, this is a bit shady, but okay. But when you do it like 6 times, or as to why MVP as a design pattern on Android was never a good idea, you end up doing this each time when there's a change or when you're restoring your state in the presenter, right? Like you would need to invoke the right callbacks in the right order to set up the right thing of the right state of another object. You end up seeing that this doesn't even work. So MVP, as people used to do it, was basically just a non-reactive way of state management, and it basically has all of the problems of this coupling that is required, that you need to remember exactly what callback to call after a given property is changed. But when you have reactive programming, which you can do easily with either behavior relay from Rx, with mutable live data from, well, a safe state handle, because why else would you have another one except for loading state? That shouldn't come from a safe state handle. But anyway, so with mutable live data or a state flow, flows in general. So you have these, and they are nice because when you change the property, this observer logic, this callback, is basically part of this type. Like, you cannot change it without this listener being called. Like, all of this is just a wrapper around the observer pattern, but because they have this shared wrapper, like either live data or Rx is observable or flows, you can apply additional operators to them, including things like filter, and then say that I don't need to know about these unless this condition is met. Or something that's like basically the foundation of reactive state design is combine. You can combine any number of these flows and observe that if any of these have changed, then I want to be notified. So imagine that you have these 4 properties setting up a view, like this search text is needed here, this filter is needed here, like that you can like exact example, you can search for title with an edit text, there's a filter for a type, and let's say there's also a date filter for whatever reason. And this is 3 different fields, 3 reactive fields, each of them can change independently. So when you mutate them, then each of them changes independently. That means you don't need to like say dot value, copy, blah, 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 because they are all independent. So they are independent observable fields, you combine them, and the way you get your final result for this result filter is that you have all 3 properties. When either of them changes, you get a notification for it. You just return the query results from that, and tada, you have the asynchronously evaluated results based on these 3 properties. Instead of having to be like, when this changed, then call this callback and hope for the best and then notify the view and all that. No, you just say dot value equals this new property value, because dot value equals whatever. And the way it's set up, you set up this chain, this combined chain, like you combine these 3 properties, you switch map to the query result, and you observe it. And then you don't need to care about like having to check if the data set underneath changes, because the query results coming from room, for example, they are fully reactive. You don't need to check if the calendar was somehow selected a wrong value. Like if you press the clear button, then I have to reevaluate this. No, you don't. You just change this one value, and everything that depends on it is automatically updated for you. As such, it's much less, it's significantly easier, and you can even manage asynchronicity this way, because it's just one state that this thing is null and now it isn't. Instead of having to like manually check, okay, is it still null, or no, you just get the right value right now. You just observe it and you will know exactly what you need. And if you need to know about anything else, you just also add it to the list of combined properties and you get those as well. So that's practically reactive programming in a nutshell. You can define these chains between these observable properties, and you never need to manually say that, okay, this also changed, because you get that done for you by combine, as in like combine latest, the operator.
Yeah, I'm using React. I mean, it's pretty common to use reactive data sources on Android now, right? Because live data was a version of that.
Yes.
More like a lightweight version. Before that, we had RxJava and now Flow, and they all do a bit similar things with some little differences.
Yep.
And yeah, in my little hobby app, it made my life really easy to have this observable data, because everything is synchronized automatically, basically. Because Room also can return Flow and live data and Rx observables, I think, right out of the box. So whenever a table changes, you get these updates. And this way, you know, when I show information from a room table somewhere, this is up to date. I don't have to make sure that I fetch this again. It's always the latest data. And this really makes it easy to have different screens that all read from the same data, but you want to make sure that they are actually updated and in sync between each other. And many people were wondering why you still prefer RxJava over Flow. I have no experience with RxJava. I only used live data and Kotlin Flow, but Flow and Rx seem to be very similar. So why do you still prefer to use Rx?
the short answer to that is that Rx has less quirky behaviors. Like with flows, it kind of shows that it's new in a sense that the way, well, it's not really refined. The API is not really refined, I feel. Like if you look at just debounce, which is a very common operator, it's experimental. You look at the internals and you don't really get ahead with it. There are all these tricky things. And
debounce means that you get the value after a certain amount of time. For example, when you want to search for something, but you don't want the search to trigger immediately. You want to trigger it automatically, but after like half a second, after not typing something, for example.
Yeah. Because that way you don't like, especially if you would be sending API requests for like each step, you don't want to do that. You want to like wait so that, okay, now the user stopped typing, now we should just send it up. And this is a really common thing. And when I saw that flow debounces experiment, I'm like, are you sure about this? Like, is this stable? But the real issue with flows was that, what was the specific quirky behavior that made us not want to do it? It was really tricky to execute something in a super scope, coroutine scope in a way, right? Like I have this view model with the view model scope. I want to run something that should run in a singleton elsewhere and then know about it later. And the only way to do that would be to like run the whole thing in that super scope. So structured concurrency is theoretically a blessing because it prevents you from doing this. But then when you need something like this, you're like, okay, what do I do now? And what you do in the end is replace it with Rx, or at least that's what I did. But I don't remember the exact details of this particular thing. I'm not sure what I was trying to hack around with. But with Rx, you have better control over when you want to create something and destroy something. It's not like you have this job somewhere and you have this coroutine scope somewhere, and then you can cancel the job, you can cancel the scope, you can cancel the children of a job, you can do all these things. There's just so much more extra complexity that you need to care about when you're using coroutine flows because of how it's built on top of coroutines, which were already a complex framework. Like, they are nice, but you also need to care about catching the Kotlin cancellation exception, which is something you don't need to care about with Rx. Did I say having to catch it? You need to rethrow it. That's the opposite of what I meant. Yeah, you need to rethrow it. If you catch it, then Kotlin cancellation exception will break. But on the other hand, you see Google code where they explicitly catch Kotlin cancellation exception. And I'm like, I'm not sure what's going on here.
So if you don't rethrow, then the coroutine doesn't cancel at all.
It won't be able to tell the scope above it that this scope should be cancelled. So that coroutine will run to the end. And whoever tried to initiate a cancellation won't be able to do that.
Yeah, that's really a thing that seems easy to miss.
It's super easy to miss because you just say try catchy throwable anywhere in the code. Any code that catches it and doesn't explicitly check for Kotlin cancellation exception to rethrow it, which is pretty much all code that doesn't work with coroutines per se. Like, it just one library that you pull in has this thing that try catch throwable and just log, for example, because I don't know, it's a bad library for whatever reason, and they wouldn't rethrow it, or it wraps it in a runtime exception, and then you need to check if the cause is a Kotlin cancellation exception, for example. You can't really know this. So as such, I don't really trust the cancellation in coroutines. And as such, I prefer Rx because I don't need to think about it. It just works, especially if you use behavior relay.
Yeah, the nice thing about Kotlin Flow is that it has structured concurrency where we launch a coroutine scope and then we make sure that we cancel it at a certain point if we don't need it anymore. And this takes care that all the work that we launch inside the scope is then also automatically cancelled, right? And that we don't keep anything running too long or indefinitely and get a memory leak this way. So for example, we have this ViewModel scope, which is automatically, which you can use inside a Jetpack ViewModel, and it's automatically cancelled when the ViewModel is cleared. And any work we start inside this ViewModel scope any suspend function is automatically cancelled when this ViewModel scope is cancelled. So we don't keep anything running longer than we were aiming for.
This is kind of true. For one, yeah, it's the suspending functions. For two, if you have a suspending function with a while true in it, it would still...
Yeah, it's cooperative.
It needs to be cooperative, which means that it needs to be like ensure active in the right functions so that it can throw a Kotlin cancellation exception when it...
Or call one of the library suspending functions, because they do this all internally.
Well, yes, they also have ensure active, but like, yeah, if you don't know if you're calling any of the library functions, then you need to call ensure active.
Or you can call yield, as far as I know.
Yeah, I don't think yield would get out of a loop.
That's what they write in the documentation, I think, that you can call yield. I think so.
I guess yield internally also would have ensure active in it, because that would make sense. But yeah, it gets out of the loop with an exception. That's the Kotlin cancellation exception.
But does RxJava have structured concurrency, or how do you handle it there to make sure that you cancel work when you no longer need it?
Well, if you have something like a while true, then that's something you still need to care about, of course, unless you are using like observable from iterable, and then everything is an Rx operator and not a loop. But I think that's typically overkill in most cases, unless you want to execute like an asynchronous operation for each element. So the way you would handle it is either to have everything as an operator, because between operators it also checks if cancellation happened and then just not execute anything after. Or another thing you can do is to just keep it so simple that you don't need to actually rely on this. Like most of the Rx code that I need it for is for like the ViewModel properties for me are in the scope service are behavior related. It's basically just like mutable live data, but it's Rx based for its operators, so that you can like debounce them, combine them, filter them, blah blah blah, as you know. And then I just observe those on the fragment side of things, and just add the subscription to the composite disposable and clear the composite disposable when it's no longer needed. So those complex chains that people tend to talk about, how Rx makes everything unreadable because you use maybe and then completable, and then what else was there that people use and I don't? Like, I just don't write that sort of Rx code. Like, I try to solve those in different means. So as such, what structured concurrency offers you, I just don't rely on that.
Interesting. And then you're also popularly known for not being a fan of MVI. So let's start with, what's the differences between MVVM and MVI?
Okay, so I did mention previously that MVP is practically just having to manually invent reactive programming with callbacks in an imperative manner. Like each time your state in the presenter changed, you would need to synchronize that manually to your view, so that the view would also have the right state that the presenter had. And you either ended up with like no state in the presenter at all and all state in the view, or you would end up with like this synchronization logic that was callback based and not observer based. Like you would be able to get out of sync, and this was most notable after like restoring a presenter state from process that which would tell the view what to show, and you're like, I'm calling 13 callbacks manually. Are you sure that this actually made my code less brittle? And obviously the answer is no. So MVP was never a good idea. So they came out with MVVM, which is practically actually MVC. Here's the fun fact, like MVVM really is just MVC, because the original MVC said that you have the view, which would be the view inflated from the XML. You have the controller, which can get the events from the view, which is the controller, which is the activity and the fragment. Like they were always called view controllers, right? So it was the controller for the view. They are actually controllers in that sense. What people never had though back in the day is a model. So the model in reality, in this case, is the view model, the Jetpack view model, the scoped service, the thing we talked about earlier. That is the model in this separation, the thing that describes the data that can be reactively observed by either the view or the controller and then delegate it to the view. So in the case of Jetpack Compose, this is automatically propagated, right? Because Jetpack Compose observes everything. But the model itself is the thing that stores the properties that can be reactively observed and combined and all that stuff. So back on track, MVVM. MVVM is really the simplest way of implementing a reactive state and reactive state management in general. So what does MVI do for us if what we had in MVVM is just a class that has reactively observable properties and functions that can change it? Well, MVI comes in and says, okay, I watched this talk from 2017 by Dan Abramov on Redux, who had this in-memory synchronous to-do list of strings where he had to create these objects that were completely typeless because it's JavaScript that described actions that would mutate the state, which was an object that was typeless, therefore kind of like a bundle because this is still JavaScript, and then hope for the best. And then each time you would click something, you would create this action, it would modify this state, and then you would make a copy of this state, and then everyone who observes this state would be notified of the state changing. So that was basically the idea. What we need to take into consideration here is that this state was a JavaScript object. It was a JavaScript object, it was mutable, and you needed an immutable copy of it so that any observers that depend on the old version of it would not have problems seeing a newer version of it while the old version of it was also modified. If you've ever had a recycler view that didn't do diffing because you mutated an array list or something, or you changed the var argument that you shouldn't have when you're doing reactive programming, like stuff should be immutable, and it's specifically because of this, it would break the diffing, right? So
a var variable in a data class.
Yeah, a var variable in a data class. So as such, you don't have these mutable variables, and Redux invented the idea that an object can be copied so that you have an immutable copy of it so that you can make changes based on the old version and the new version, and not just like have it change in place, while other places might not be notified of this thing changing. And that's where mutability bugs came from, and that's what reactive programming aimed to eliminate, right? So they practically created a mutable structure and tried to fix that it's mutable by having to copy it all the time each time, which makes perfect sense because it was a mutable thing. And then have one observer because, JavaScript was a typeless language, so you couldn't really combine anything and then get it in a type-safe way because there's no type safety in JavaScript. So as such, they don't have what we have here in Kotlin, which is tuples. They don't have tuples. They don't have them because everything is typeless. It's all a string key path thing. So why we are talking about this is because Redux is the origin story of MVI. We have this state object with everything in it as like a wall in one object, and then everything is nested in it because Redux did the same thing. There's no other reason for it. That's the reason why it exists. So then people may ask, hold on a second, isn't it because it's a state machine and it's a reducer, and then because it's a state machine and a reducer, then you have to have it as one property? Yes, but no. But like you have OOP, you have encapsulation, you have private mutable fields that are mutable, you can expose them as observables. These are all things you could do because we have type safety and a statically typed language. We don't need to combine everything into one object in order to see these properties. We don't need to, so back on track. MVI inherited this from Redux. It inherited the idea that you need a reducer to change state, but you don't. You just need a function. Any function would do. So MVI said that you need to have one function that changes anything and everything about the state, And if you went all the way to Redux, then it would say that there's this one function that changes everything in the entire app. This one function. And if you know what coupling is and accidental coupling and all that, it's when you have these completely independent components that can touch each other's internals, like you modify this one thing and this other thing breaks. And it's because this thing depends on this thing in such a way that is totally unexpected. They're supposed to be independent and they're not. So how can this happen? Well, with Redux, you have everything in one big state object. And thankfully, MVI is slightly smarter than this and doesn't try to move everything into one singleton global object that has all the state of all the screens in all of the app, right? Like, this is the idea of Redux. This is what MVI partly inherited. So in MVI, you have this one function, it gets these actions, and they had actions like this in Redux because they don't have types. They don't have functions. You would need to call this one function because if you add another function, you will not discover it. There's no type. There's no auto-completion to tell you that it exists. So yeah, you would have this one function and you would add this one additional string key, I guess, for this new function because you basically implemented message passing, which is practically function calls. And in the case of two ViewModel communication, it's synchronous. So when people invented MVI and they said that this scales better, they basically just added more sealed classes to model function calls. And it does exactly the same thing. There's no change in behavior at all. The only thing you did is move them all into one function and then do a huge when statement to have every single function call that would be a separate function in one function. And that's when they run static code analyzers on this code, they always add suppress warning, cyclomatic complexity. Because they're like, but this is MVI, this is best practice. Clearly the static code analyzer is wrong.
So if I understand it correctly, it's not necessary on Android anymore to use this.
It was never, because we have types. Like, because we have a type system, even in Java, even in Kotlin, of course. Like, this is not JavaScript, and we inherited a solution to a problem that we don't have, because it was a solution in quotation marks in a JavaScript typeless world.
But why does it have so many fans? Why do I read so much?
I don't know.
Why do I read so much about MVI?
I guess because there was one popular article about it and nobody questioned it. I think that's basically what it was. Because back in the day, the way it worked is that it was one-to-one with reactive design. And it's because of Google's sample code, right? Like, what Google sold as MVVM code was actually data binding based code, but not even good data binding based code. Because the way data binding was able to work, observable fields were able to define dependent observable fields. So you were actually able to write reactive programming with observable fields. But nobody did that because it was very verbose. So I have not seen it done anyway. So as such, people were like, okay, but MVVM, well, I have all these observable fields, and to show a dialog, I need to set this observable string to something like an empty string and then null it out. And that was not MVVM. That was just Google sample code. So as such, people were trying to find something else that looks more structured than whatever Google was coming up with. And that was MVI.
So I don't have any experience with MVI yet. You have, whenever I got into it a little bit and I asked you, then you just really talked me out of it. But yes. This is a bit of a problem right now that I don't really know how it works. But maybe for people better to understand, maybe you can list us how MVI does something and how MVVM does something and why MVVM is better. For example, these function cards. Maybe you can give us a list of these different things. Yeah, how MVI does them, how MVVM does them, and why do you prefer the MVVM way of doing it?
Okay, so the overarching topic here will be that more reliable and less complex. So in that sense, If MVI does the same thing as MVVM but with more complexity, then MVVM will be inherently better by doing the same thing with less complexity, right? So for example, with MVVM, you have 4 properties, each of them mutable live data of string, mutable live data of int, mutable live data of, I don't know, some immutable object, let's say. And in MVI, you have this state class that has these as walls, all of them as walls, because MVI forces you to have this class and have these fields in it instead of being able to observe each of these properties independently. So you can argue that, but I can observe the state, the whole state, and you're right. But what if I want to debounce changes in the search text, for example, and I don't need to debounce the whole state? I only need to care about changes in this. And the MVI answer to this tends to be that, well, you should debounce it before you modify the state. But that's not what I want. I want to update this text and then observe it for changes and reactively update my query results when that's done. And you cannot do that with MVI anymore because everything in the state is a normal wall and the only thing that is observable is the state. So that's the primary reason, that's the first and foremost, the simplest feature, that if you have MVI, that you can't even describe it because of the way the state is structured and is saved as one mutable live data, for example, or one mutable stateful, whatever you want to call it. If you have mutable stateful state and you extend from, like, I don't know, Maverick's Rx ViewModel or something, I don't know, something like this, then you lose the ability to independently observe your properties. So MVVM, you were able to define any change, and only observe like a subset of these properties to maybe even derive some new state from 3 of them and expose that. So you would have like all these 3 properties and there's this one that's computed. This is something you can do. You can't really do that with MVI unless you manually do this in a reducer, right? Because there's this one reducer function. Okay, I will go back just one step back. So the way it works is that when you want to mutate the state, with MVVM, you just update the observable property and it updates the reactive chain because, well, you define the reactive chain with combine and all the operators execute as such. It's just notified. In the case of MVI, you don't have this luxury because while you have reactive state observation, you observe the state reactively, the evaluation of it is still imperative. It's practically callback based. So what happens here is that you pass this action into the MVI reduce function, which will then grab the current state. It's like state.value equals state.value.copy, and then you make the change. So you imperatively grab the state and then you modify it in place. Now this is when the real issues start to happen, which is, okay, but I need to update this state later because I need to fetch something from the network and then I grab this data and then set it on the state, right? So that's what I want to do. How do I do that? And the answer to that is tricky and twofold because there are 2 things you can do. You can either say that, yeah, my state can be mutated at any time, so they offer you this state accessor, and then whenever you want to access the state, you access it from there so that when you actually want to make the modification, you don't get an outdated state. This is one thing you can do, and what some MVI libraries do. And the other one is to strictly serialize every single mutation call made to the state, which is what Uniflow KT does. So these are your 2 options, and then you ask yourself, why do I need to strictly serialize every single mutation call made to this state just because I have one asynchronous operation somewhere on the screen blocking every single other change that can happen on the screen? And this is a sickness of MVI's core design, is because you have this one state and you need to imperatively await that something will change at some point. And if you don't wait, then you will get outdated state and your copy will be outdated. So changes can you save this one state, and in the other place you would have an outdated copy, and this previous state modification would just not be there because you had this outdated state in the other one. And this is what MVI libraries solve for you, so that when you have this state accessor which will give you the current correct state, right? And these are all things that would not even happen, because all you want it to do is execute an asynchronous operation, and when it's done, just set the result on an observable property, and it would trigger the chain automatically, and it would reactively update the state that is observed by the view anyway. So none of this was needed. All of these steps were unnecessary. The very concept of having a loop that runs around and around to process these actions are function calls for anything that you can do. You can do them without this loop. You never needed this. You never needed to block it. And the funny thing is that if you check Redux tutorials, because that's where this all came from, they actually have sections on how to avoid race conditions by using Redux. These race conditions would not exist if you only have these observable properties that MVVM gives you. None of this complexity is warranted. None of it is needed. And people tell you that, but MVVM won't scale. Why wouldn't adding an extra property scale? Like, the other alternative, what is it? Is that you create CL classes to model functions, and that somehow reduces complexity? No, you reinvented a language feature with higher cyclomatic complexity. You bound together every single independent property of a screen, introduced additional coupling that never existed, prevented yourself from defining reactive operators on independent properties, and now what you have is, well, the feeling that you've achieved something, because if it is this complex, it has to be good. But it's not. You never needed any of it. That's my issue with MVI.
Okay. Yeah, it's hard for me to understand all of this because I have no experience with MVI. But I want to clarify something you have mentioned earlier, and that is that the view model, the Jetpack view model in MVVM is the model in MVVM. And this might confuse people because by default you would think that a view is the fragment, or I don't know, the composable or the activity. The model is the repository and database and everything below that. And the view model, the Jetpack view model, is the view model in MVVM. But why is this not the case?
Well, that's a tricky one. And if you read the comments on Reddit from the original creator of ViewModel, then you know this, but that was 2017, so you probably haven't seen it. It's called ViewModel for the same reason that view controller is called a view controller. Because it is the model of the view. It is the model. So when you talk about MVVM though, originally, well, that's a tricky one, because what it did was expose these observable properties and derived states and whatnot, just computable states and whatnot, just like before. But in that case, the only key difference there, as defined by Microsoft, was that the bindings, the observable bindings from the view to the model was actually done in the view using data binding. That was the core idea of MVVM. So what we have is MVC, because the C, the controller, it's actually more like MVP in this regard, to be honest, because it is the controller that subscribes to the model and passes them over to the view in the case of the XML world, while in Compose, you don't need to pass anything manually, because the view is the rendered composable, and the controller to some degree is the composable that has the states. So like, if you think about it, the event handlers that you give to like modifier clickable, that's the kind of thing that the controller would do. And that's the code that exists. Everything else is just rendered on the screen. So in a sense, the Compose combine these, but on the other hand, the model observation is completely automatic. I don't know if that answered it.
And what is your opinion about clean architecture? And just as a note for the people watching this, we have to rush a little bit through the rest because we're already at almost 3 hours into the episode. So the rest of the topics will be a bit more rushed, but we might make another episode in the future where we go into more detail about the remaining topics. But yeah, what's your opinion on clean architecture? Do you use that yourself? And what's the difference to normal MVVM in a quick summary?
Okay, this is a fun topic. So clean architecture as an original concept, it just basically said if you have a third-party dependency that you don't trust, then you create an interface so that you don't see it, and then you can swap it out later to like have matching behavior, but without depending on the exact specific thing, right? While that somehow managed to become in the Android world that things should be data domain presentation split up at top level modules, you have a data layer that's specifically and separate, that should both have the database and the network for whatever unknown reason. Then you would have this domain which has these nebulous use cases that sometimes do something, but in every single sample code you see, it's literally just either doing what the data layer should be doing or just delegating directly to the data layer. So that's when you realize that you either don't have use cases and your app is doing nothing, or your domain layer is like lying to you. I don't know. So you had this domain layer, which in the worst scenarios was also like platform agnostic, even though the code was always only ever used on Android. So any benefit of trying to like make it multi-platform compatible was like completely needless. Like you impose these restrictions and you're not even relying on it. So why are you doing it?
I actually think we can combine the topic of clean architecture and testing and really put this into another episode, because then we can go into more detail. Because I have questions about testing specifically. And maybe we can combine this with clean architecture, because this is also about separation and modularization and stuff like that. So maybe we do another episode for these topics to go into more detail about them. What do you think about that?
So that means that we've finished now?
You can still add stuff that you think is important for the topics we covered, but we will cover testing, and also, I guess, Kotlin multi-platform is also interesting in a later topic.
KIM will have to be elsewhere in that regard.
But everything that you think is still important to cover now, you can just tell us now.
Okay, sure. So the issue with this clean architecture setup that people talk about as clean architecture is that data domain presentation split. It's considered an anti-pattern, and I don't know why people are still doing it. I have an article on it explaining how even the original author who said that, yeah, this is clean architecture, you should do this, eventually wrote an article 3 years later saying that this does not scale, don't do it ever. So that's why it's funny how you just see these pop up, you go to a sample code and it says data domain presentation, and you're like, oh god, not again. It's literally worse than having them in one module. I'm not joking, it's literally worse because the split is wrong. When you need to make a feature change, you would modify each of the modules. All three of them each time, which is oppositional to the idea of modules being separate independent entities. They are supposed to represent boundaries between your code. And if you need to modify all three of them for each feature in any of the app, then something went horribly wrong. So in that regard, for modularization, just pretend you're writing retrofit, like the actual library, and that's how you will end up with an API that makes sense, and pretend that versions would cause breaking changes because it's a library. So if you want to like create good modularization, then this is what you have to keep in mind, that someone will consume this as a library and that any breaking change would be breaking to those consumers. That way you can ensure proper boundary separation between your components. But this is pretty rare when it comes to apps. In apps, what you see most of the time is screen-based modularization, which can be okay. One time I had to swap out Google Maps with Huawei Maps, and I had to do that at a module level. So in that regard, this modularization scheme was actually useful. There are many times when it's not, but in this case it was. Any other tips on top of that? I have an article on it on how you shouldn't do what the Google I/O Talk said in 2018, because they basically told you that if you want to do cross-module communication, just use reflection, and that's not a good idea. Like, you're not supposed to have to know about another module that you are not depending on. At that point, you could be depending on it, and that way you would not even need reflection. You wouldn't even think about the idea of using reflection to do it. And that's basically what people were doing when they were like, okay, we created this tool that generated the activity names in a global module so that we know all the activities in the app. Like, you're not supposed to do that. You're only supposed to talk to the parent. You don't know about the others. You've just coupled your modules together. This is the opposite of a modular design. One more thing that's important. I want to do like one sentence on testing. Testing is about automating the behavior of your code. Anything else is just arcane stuff that you don't even need to think about. People do all this mocking and all that, but they are not really automating the behavior. What you want to do is automate the behavior of the real code. You start faking if you can't. That's the general idea behind unit testing.
Yeah, we will talk about this in more detail later.
In some other time, yes.
Yes, because I'm also interested in this. Because at the moment, I'm really getting into testing.
This is the teaser, Taylor.
Yes, that's the teaser for the next episode. So people should definitely subscribe. And yeah, this next episode,
don't forget to like and subscribe.
We also want to talk about KMM a little bit, Kotlin multi-platform mobile. And I also was going to ask you about your approaches to learning from reading code and so on, but we will
do that some other time because I will have to leave as well.
Okay, we do this in the next episode. We make sure to record this soon. And if there's nothing else you have to add, then the only question left is, besides your talks, which I will link below, and everything we have mentioned so far, where can people find out more about you? Where should they reach out to you? What social media platforms?
Send me stuff on Twitter. I'm primarily on Twitter. Don't even bother on LinkedIn.
Zhuinden on Twitter.
Yeah,
and EpicPandaForce on Stack Overflow.
EpicPandaForce on Stack Overflow. And there's actually this /r/Android Dev Discord. Yeah. On that one, I'm using my gamer name, which is ZoomGamer, but I actually also have the name EpicPandaForce there. So that's also a place where people can tag me, but I only have Discord on my PC open. I don't have it on my phone anymore.
Okay, nice. Then thank you for coming in the show.
Thank you for having me for 3 hours.
Yeah. I have to say, after 3 hours or after 2 hours, it starts to become really difficult for me to follow along. But yeah, that's right. We split up the rest into another episode, and then we can refresh and talk about all the remaining stuff.
Yep.
Okay, then I wish you a nice rest of the day.
Same. I will go have lunch.
Nice. Me too. Bye.
Nice. Bye.
I hope you enjoyed this episode of the Coding in Flow podcast. If you did, please subscribe either on YouTube or wherever you're listening to this. If you're watching this on YouTube, please also leave a like on this video and leave a comment below with any thoughts about this episode, anything you want to tell me. I actually read all of these comments. I don't answer all of them, but I read every single one. And if you're listening to this on Apple Podcast, please leave a 5-star rating if you think the show deserves it. My name is Florian Walter, and you can find me on most social media platforms like TikTok, Instagram, Twitter, under the handle @codinginflow. That's just one word, Coding in Flow. You're also very welcome to join our Discord server, where you can discuss programming related topics and ask questions to thousands of developers. Of course, it's free, and you can join the server under codinginflow.com/discord. And one more thing, do you want to get a summary of these podcast episodes every time I release an episode with my key insights that I extracted out of the interview? Then you can subscribe to my email newsletter, which of course is free as well. You can find it under codinginflow.com/newsletter. This is perfect for you if you don't want to watch every single one of these episodes, if you don't have time for it, but you still want to get the most important information out of it. Just subscribe to the newsletter and you will get this stuff straight into your inbox. Then again, I thank you for listening to this episode. I hope I see you again in the next one. Have a nice day and happy coding. Take care.